Sorry.
Last.
Yeah, the square brackets or just the, because you said last is a function, right? That's how we use it. But this has to be
It's the last list of this.
like this. Yeah, your voice is not actually audible at all. Still can't hear you. Hello, am I audible?
Yes, sir, you are audible. There is
Yeah.
an issue in that guy.
Yeah, it will be last of X, right? So I just want to have the station name in it, right? So maybe no, but the thing which we are asking, right, is this the way we approach it?
So we use
So
a
we
code.
don't need to have the square brackets on the end.
So will this give me a list or will this give me just the element?
Just the element.
Element.
Just the element, right? This is what it will give. And what if I want it to be a list of single item?
Then we will add the square brackets.
Right. If I want it to be a list of element, it should be last of X, correct? And then we do any of the comparison over whatever we wanted to do with it. What was the next concept we learned in lists? Hello, am I audible?
Yes, sir, audible.
Insertion sort is there.
Yeah, insertion sort, right? What is it that we use insertion sort for?
Arrange a list in ascending or descending order.
Yes. So the prime example which sir said in the lectures, right, was yeah. So we looked at sorting, right? Why sorting was needed. That some of the questions can be easily addressed by having a sorted list. Some of the questions can be addressed by using a sorted list. Sir gave an example, right? What was it?
So
Finding the
duplicate birthday
toppers.
one.
Finding
The toppers.
Same.
Three
Finding
toppers.
first
Finding.
three.
Same date of birth.
3 toppers, then same date of birth.
Duplicate birthdays.
Yeah. For such an operation where you would like to ask a question which relates to something of this sort, it is always better to have a sorted list, right? And what sorted list method we discussed? Insertion sort, right? Insertion sort. Yeah. So did we had a function for that? Hello?
We had a pseudocode for it.
Yeah, your voice was not clear. What you said?
We had a pseudocode for it.
Sir, we have a pseudocode for that.
Yes. So we build a pseudocode in, I think, lecture number 6.3, right? A pseudocode to look at. To build and sorted list. So can anyone explain me what is the basic idea of insertion sort?
It will take a card and it will go through every card and see. It will go through the already sorted list and will see where the position of it is, and then it will insert that card in that place.
So suppose I have a list of numbers. Right. Now I want to build an insertion sort. What should be my first step?
Empty list.
Right, an empty list I will build. Then I will take the first element, right? We go element by element, right? In this, in insertion sort,
Yes, sir.
Right.
right? So we need to use what? For each.
Yes, sir.
Yes, sir.
For each, we will use x in list one. Suppose this list one is equal to, for each x in list one, we will look at it. And then what do we need to check for? There were three conditions are set, right? We need to make sure when we are doing insertion sort.
Sir, we will
Anyone?
check if X is equal to the empty list.
Okay. So first we check, or first we just put first element into the list?
Yes, sir. First, we will give the input in the empty list, and then we will check if that same variable is value is there in the whole list or not.
So I should do what? Your empty list, suppose this is L1. Let's say this is Z1. Z1 is my empty list. So I am iterating through list one and I want to sort it out. So for each X in list one, what I will do? Oh,
So we have to will check that
is equals to false.
sorry,
So we had to write inserted is equals to false.
for each X in list one, if
Sir, after we created the new list, Z1 is equals to the new list. After that, we had to write inserted is equals to false. So that in condition, when we write for each Z or X in list one, if not in
then
bracket inserted.
even before that, we need to define what inserted is, right? So
Yes, sir. Inserted is equals to false.
inserted is initialized as false, right? And then we are looking at for each X in list one, if not true. If
Not inserted.
so it should be inserted, or should there be in bracket?
Yes, so there should be a bracket
Why?
because it gives a Boolean value and we need to check whether
That Boolean value is true or false.
right.
Okay. So let's go home. Yeah. So then we look at what?
X is less than Z.
What is Z here? We haven't.
Z is the element in Z1 or new list.
No, but we have this.
Sorry. Sir, I said the opposite.
What? If X is less than is it right?
Yes, sir. If X is less than Z1.
If
So
no,
we
define
need, so
our
we need
element is
another,
X, right?
so we need another for each loop that will go through Z1.
Yeah, no, Z1 is an empty list, right now. So for the first one, we have we are going through each of the element of the list one. Then you are saying that we need another loop which will go through for each, say, A in, okay, let's say Y in Z, right? Z1. This is what
Yes,
you're
sir.
saying. Then you have, I have to take care of that also. Okay. Yeah. Then,
Sir, would it be list one?
sorry,
Sir, in for each line, won't it be for each y in list one? We have to check the list one and then we'll update the Z1.
Yes,
so you have,
because that one is empty.
yeah. So let's just look at the way we go step by step. I'll just write it down. Okay. What we wanted to have an insertion, we wanted to have a sorted list, right? And we are going by brute force method, right? So we have a list. We have a list of elements or numbers, right? In this case. So then we go through each of the element and we go through the each of the element. So do we compare this element with what? So we need to define an M list. Now you tell me. Instead of going through all of this, right, complicated structure, let's go statement by statement. What would be your next step? Each of the element of the list. Okay. This I will call explicitly empty list, and this let's say we have a list 1 and each of the element of list 1. Then
Check.
We go through each of the element of the new list and we check where we compare it. We compare every element of list 1 with list 2 and check which position it would be in.
okay, so then we go through each of the element of list 2, correct? And then check if the element in list 1 is smaller than list 2. Is it correct? List 2 element.
Sir, if we are doing ascending, then we'll check for
Greater than.
yes, sir.
Let's just go with that then. Okay. For ascending or descending, the concept should remain the same, right? So check if the element in the list 1 is greater than list 2, all the elements. All elements of list 2. Is this right?
No, we won't need to check for all the elements, right? If we hit a position where the element of list 1 is less than the element of list 2, then the list 1 element will need to be inserted there.
Yeah. So what we need to do is that in this scenario, check if the element in list 1, right, in this list 1 is greater than which, correct? Which element of list 2? Is this correct? Place or insert. Sorry. Yeah, place or insert the element from list 1 in list 2, correct?
Yes, sir.
Yes.
Okay, so we know where it should go. And then what we'll say? So we have decided that we need to define what? Define a Boolean variable, right?
Yes, sir.
And set it to false, right? In here, then we are saying that set the Boolean variable to true.
Sir, I have a doubt.
Yeah.
Sir, in this statement, you have written that check if the element in list 1 is greater than which element of list 2. Sir, I was saying that at first the list 2 is empty. So we are adding the elements from list 1 and we are adding in a organized manner. So we not need to find which element of list 2 is greater than or smaller than, right?
No, see, you eventually want, you have a list, right? You have a list, suppose for this sec, right? You take the first element, which is 213. Now you need to check whether that element, like whatever element, right now we know that Z1 is empty, right?
Yes,
But
sir.
what if once we add some element to Z1, Z1 won't be empty anymore after first iteration, right? So in the first statement, you cannot assume that Z1 is empty. You need to check for any element. So in this case, now there are no elements in this, right? So we will check whether this is equal, greater than or less than whatever the element it is in here. If it is not true, then we will append.
Yes, sir.
Right? That is what we will do. But if it is there, then sorry. No. Can you come again? Are you guys able to hear her clearly?
No, sir.
No, sir.
Yeah. So, yeah. What were you trying to say? Can you come again, or at least put it in the chat section for me to see?
Can you please what is the question?
We wanted to just look at how we build the insertion sort procedure, right? So we are just looking at what is the logic with which we are going, right? So we devise set of statements to go with it, right? So we wanted to check whether we take an element in here, do we need to compare it with any of the element in the Z1 and place it where? All of that has to be decided. So how do you go step by step for that? So we said that was the question, right? That was your question. Hello?
Yes.
Yeah. So we are looking one by one. Yeah, so we are looking at one by one how sir has built the insertion sort algorithm just by using lists, right? The reason why we are doing this procedure is that when you go and look at the question which is being asked in the exam, right? Try to think it in a smallest possible blocks possible and then try to rearrange them to arrive at a final answer. So there are various ways to go by depending upon what question is being asked. So in this question, I just wanted to know how we will build a sorted list of insert, or how we will do insertion sort, given this is the example. Okay, so we are going by Sir's method where we have an initial Boolean variable declared to be false. We have an empty list, and now we are going to do certain set of operations on list 1 in order to obtain a new list Z1. Okay, so yeah, so we were here, right? The question was, because we don't have any element right now, but suppose in the first one there is no element to compare, right? So we'll have sorry.
Sorted list.
Yeah, your voice is not clear actually. So the first element would be eventually 213. Okay, let's assume that was the case. And then now I wanted to place 654. And we are going in, how do you want to go, ascending or descending?
Okay, what a sorted list is.
Yeah, ascending.
There is sorted list.
Hello, the sorted list would be in this scenario, right? The odd number list which we have shown here is a sorted list. It is in a particular order. So we see that 1 after 3, then 5, 7, 9, and 11. So it is in what? Ascending or descending order?
Ascending order.
Hmm?
Ascending order.
So we want to, the sorted list concept is introduced for you to understand that given a set of list which you have, a list which you have, how can you build a sorted list out of it to answer a question like, finding first three toppers or same date of birth, something of that sort. Okay. So for that purpose, we are discussing what was the sorted list which was discussed. I think this was one of the important concepts which we covered in the lectures, in the all the lectures related to lists, apart from the side effects. So I just wanted to know whether you guys understood the concept or not. So we are going, line by line.
There was a problem. So we just explain the code alone once again. Because I have watched the lecture, but I could not understand.
Yes, sir. Please, can you explain again this pseudocode?
This pseudocode, no? Or the pseudocode by sir?
This one which above.
So the pseudocode you have written, the above one.
This one, right?
Yes, sir. Yes. Yes.
Yes, sir. So to build this pseudocode, we are going line by line. I'm asking you questions and we are getting an answers from you one by one, right? So we were asking, so for any pseudocode to start with, right? To build a procedure where we want to create a new list which is sorted, we need to first define an empty list. So we define Z1. Original list, we already have list 1, which is not part of the procedure. So procedure or whatever procedure you will put it here, this list will be sent to this particular set of code. Okay. So we have two set of variables. One is empty list and another one is your Boolean variable, which is being defined as follows. Now we know in suppose. Yeah.
So, and we will call this procedure sorted list insert, and then we will put. We will call this procedure sorted list insert, and then we will put the name of the list in curly bracket and the element that we want to put inside of it.
So in this, what do you call, in this particular?
Not inserted.
Sorted list insert was a different function, I think, in which
Yeah.
the list was already sorted.
Yeah, so in a sorted list insert function, you wanted to put this variable and you wanted to decide where it had to be put.
Right, so
that is different. We want to have an insertion sort list, like that algorithm, in order to get the list to be sorted.
So insertion, you just have to add other elements to the list.
Sorry?
So insertion sort means, can we say we have to add another element to the list? Adding an element to the list.
We have to add
An element to the list.
Yeah, your voice is not clear. Can you put it in the messages? Is anyone else able to hear her clearly?
No, sir.
Yeah. So do you remember what sir did in the lecture? Is he building a full insertion sort pseudocode, or we are using this sorted list insert function to build a sorted list?
So he did both. First, he taught the pseudocode for insertion sort, and then he did a pseudocode for sorted list insert.
So let's look at then the both. Okay. So this is not what we are doing right now, right? So we just wanted to have sorted list. So to this list, you are going to provide only a list, right? You don't even need a procedure for that. Hello?
Yeah.
Yeah, am I audible?
Yes, sir.
Yeah,
Yes,
yeah.
sir.
So I'm asking you. So what would be the, forget about the complex question of, building actually should. I'm just asking you, given a list, how will you do a sorting of this list? By using insertion sort. So what was the first step of insertion sort?
Create a new empty list named anything.
That's
it
not
can
here. You're trying to sort the list one. Sorting the list first. Probably ascending or descending. Let's on some order.
Can you come again?
Are we trying to order the list one? Ascending or descending?
Yeah, let's say I want to have it in ascending order.
That's the purpose of insertion.
Hello.
So can you say the purpose of insertion sort is to order the sum list?
Yeah, we want to order it, right?
Yes.
So we are asking the basic question, how do you proceed given you have a set of list? What would be your first step? What would be your second step? What would be your third step when you do the insertion sort? Do we, compare only the first two elements first?
We compare all elements.
Anyone else? Your voice is very.
We compare each element of list one with all the elements of list Z. We compare one element with all the others.
Okay, so we take 2, 1, 3. So for each X in list 1, what I will do? Then if X, then again, we need to have what? Last, right? Rest list will be equal to rest of list 1.
Yes, sir.
Right? Then, sorry. Yeah, so we have to do for each Y in rest list. Then you have to go and ask this question, right? If X is what? X is less than Y. So we are taking first element of the list 1, right? And whatever the your rest list is defined by using rest of the list except the first element, right? Then we are iterating for each Y in the rest list, right? That way we are comparing what? First element with the second element. Is this correct?
Yes, sir.
Then if X is greater than or less than Y, what should we do?
You have to retain it in list one.
Hmm?
You have to retain it in list.
If X is less than, we need to keep the list as is, right?
Element in list one itself.
There's so much of background noise actually. Can you tell me? Just put it in the chat also. If
Am I
possible.
audible now?
Yeah, you're audible, but there is so much of background noise.
X is greater than Y, you have to retain that element in list one.
So won't we initialize an empty list?
Yeah, we can initialize the empty list, but we need to see, suppose you say list 2 is initialized as an empty list. How will you use it?
Sir, we
Then
can
we will append X in list 2.
Sorry?
We will append the element X in list 2.
Okay, so let's just say, so list 2 is equal to list 2 plus plus what?
X.
X, sorry, X, right? Next,
sir, we can have a variable which keep tracks of the last number which we added in list 2, and we can go and find the what is the minimum number in list 1, add that number, and then change the value of the variable to that number, and then now we check which number is greater than that number but still the minimum, and then add that number and then reinitialize the value of that variable to the second number now.
yeah, but in insertion sort, right, we usually compare 2 elements at a time, right? Then we move to the next 2, then we move to the next 2, correct?
Yes, sir.
Am I correct or? So say when I append this to this list X, right? Might I also need to append the rest of rest list?
But sir, in this case, X will get appended several times, right? Every time X is greater than Y, X will keep on getting appended because we're going through the entire rest list.
Yeah, so so if X is what, less than Y, we wanted to append to the list 2, right? But then we don't have any of the element in the list 2 itself, right? So the next time, let's say, where is our list 1? Yeah, this was our list 1. Okay, just take this example. Okay, so this is our list, we know that. Okay, in this first
Yes, sir,
scenario,
first increment list remains same.
yeah, so in this scenario, the first X it will take. Okay, X is what? 213. Your rest list is
From 654 to 870.
right. So this is your first, in the first loop, is your rest of the list, right? Now you are saying that you want to compare whether 213 is less than 654, right? It is less, right? It is less. That's why I am appending to the list 3. Okay, so this is done. So the next
So
will be
initially list 2 remains same.
what?
Initially list 2 remains same.
Yeah, so we are not, so once this is over, where should the loop should go? I mean, where it will go?
So we need to exit the loop after appending, right? Because next time it will go, is 213 less than 676? It is, so we will add 213 again.
So if we do exit loop, it will go from, for each loop of this, right?
Yes, sir.
So exit loop should be here or should be here?
Yes, sir.
No, sir, it should be inside the if statement, so that as soon as the if statement is executed and we have appended, we exit the loop.
Okay, so we are appending, we are exiting the loop. So the next element will be in this scenario. Now we are not into this block, right? If for each Y in the rest list, right? We went out and we are again going to the next element, right?
Yes, sir.
Now we are going to 654. But is this rest list also getting updated?
No, sir.
So we need to update it at before exiting the loop, right?
Yes.
List 1 is equal to rest list. After
Sorry?
exiting if loop. After exiting if block loop, we will write list 1 is equal to rest list.
Just a minute. List 1 is equal to rest
So
list.
what happens if exit is written after list 2 is equal to list list?
Sorry?
So what is this when exit is written after list 2 is equal to list 1?
So it will keep on iterating over all the y elements of the list 2. If we put it here, right? For each of the y till it all get exhausted, only then it will exit the loop. If we put it inside the if loop, it is saying that the moment this turns true, just exit the loop. But the point, like, the next step is really important, because now the next step you need to define is how will you update this rest list. So one of the options they said that so it should be here right before exit loop.
No. After if block is executed, right where the braces for if block is closing, after that.
Here.
Yes, sir.
So it should be what? Your list 1.
List 1 is equals to rest list.
Rest list. So your list 1 will become rest list. And then what? In your list 1, the next element would be 654. So
Yes, sir.
now your list would be like this, right? The first one will be 654. You want to check whether it is less than 121 or not. Is it less than 121?
No, sir.
No, sir.
No, right? So there is no updation. Then again it will again assign list to rest list.
No,
We
sir.
need
It's
to
not
add
out
the
of the
else
loop
condition
yet.
also.
For each
It won't get to list that rest list statement because it's not out of the loop yet.
so the next one would be what? In the rest list is next one is 676, right? Is 654 less than 676? Yes, right?
Yes, sir.
Yes, sir.
Right, we are comparing x with y. Y is changing, x is constant right now, right? X is 654. So the next one would be?
We're comparing 654 with each of the elements of list 2.
So it will come here, right? 654.
Sir,
Correct?
in this way, we will just have what we had list 1. It will just come back to us in the same way.
Yeah, so it is not sorting, right?
No, sir, it's not sorting.
So what is the problem? Where is the problem?
Sir, because we need to compare the element of list 1 with list 2.
Yeah, so you can only compare one element at a time, right?
Sir,
Yes,
Sir,
sir.
so are we comparing each element of list 1 with the rest of the element?
sir, before list 1, we can also write list 2 is equal to list 2 plus x.
Sir,
Where?
are we comparing each of the
If
elements
this
of list 1 with the
condition
remaining
is false,
list?
then we will
list?
add without applying any
See.
condition.
Sir, are we comparing each of the elements of list 1 with the rest
Sir.
list?
Yeah. Hello?
Yes, sir. Sir, what conclusion we should have to draw from this code, sir?
What?
Means what conclusion we should have to get from this pseudocode, sir?
So the point, like what we want to have is a sorted list. Okay?
Yes, sir.
So we started with 213 and all of this, right? Let's just
Right, sir.
reduce it a bit further. We just take 3 elements into it. Okay.
Sir, the text we wrote on how the procedure should be, that seemed right, so we can work on that.
The thing is that, right, when you're doing the issue here, like you need to understand, when we are comparing the two element, right, we should compare every time the pair of it. Whichever is the smaller one should get the first place and the rest will follow. Rest should kept as is.
Ascending order, sir.
Yeah. So then we will look at whether the next two pair is smaller, like which one is the smaller one. Like that, we will keep on iterating over all of the list till the list is sorted. There is one way to do it, right? So in here, I am not doing each element to be compared with all of it, right? If I have to compare, suppose we started with, yeah, this was our original list, right? So if I start with, comparing this with all of this list and see which one is the smallest one. This is not the smallest one. Then I will let it go. Another one, another way. Then I will check whether this is the smallest one. No, then I will let it go. Is this the smallest one? Yes. Then only that list should be appended with this. Then this should be out of the list, whatever list we are comparing, right? Then we will again reiterate over whether this is the next smallest one. Then update the list. Likewise, like there are two ways to do it. Either you do it, compare the two till all the list is sorted. Otherwise, you compare one element with all of it and append only if it is smallest. Correct?
Yes, sir.
Yes, sir.
Are we doing that in this code?
No, sir.
So what we need to do in here?
Sir, we need to do if y is less than x, then we need a variable and
Where we need to store the value of
the minimum value.
Right. So let's suppose I will define a variable here extra. Min is equal to 0. Okay. Now what I am saying, if x is equal to is x is less than y, min is equal to.
Sir, if y is less than x, right?
No, we want x to be the smallest one. No,
so
we want
x
yes,
is fixed, right?
So we want to see whether all the like this.
Yes, sir.
So we want to see if the y is the smallest than the x, but we just saw, right? Either we need to take one element, compare with all of it and see whether it is the smallest or not. If not, exit the loop. Then check the next one if it is the smallest of all. If not, exit the loop. Is this the smallest of all? If yes, then append to the list. Correct?
Yes, sir.
So in that aspect, if I want to go through all of this list, how will I go? Again, I will make more room. So we will always need a empty list. Z1 is equal to whatever it is. So for each x in list 1, now you tell me based on that logic, right? I want to compare whether 213 is the smallest or not. You know how to find the smallest element, right? Among the in first week's lecture, that was what our scope was, right? So we usually always have an element declared as minimum, right? Minimum should be 0 in this scenario because that's the smallest number. There is nothing smaller than this currently. So we can update that. So if
x is less than min.
X is less than, will it be? So we have to put it maximum, right? So we need to put maybe 1000, right?
Yes, sir.
If X is less than min, what should I do now?
Then min is equal to x.
Then min is equal to X and
at the end we will do z1 is equal to z1 plus.
Sir, I have a
So
doubt.
we will do this out of the condition.
Sorry, yeah. So first we need to check whether it is truly minimum across all of the elements, right?
Yes, sir.
Is X less than min? Min is equal to X. So next, whatever min, so 213 will become min, right? Is it smaller than 614?
No, sir.
Yes,
it is,
sir.
right? No, but X is what? Your X becomes 614, right? Let's just say In here, your X initially was 213, right? So 213, is it less than 1000? Yes. So your minimum became 213. So your min become 213, right? Now you are asking whether your new X is 654, right? 654. Is 654 less than 213?
No, sir.
No. Is 121 less than 213?
Yes, sir.
Yes, sir.
Yes, right? So your next 121 was there, right? So it will get updated to 121, right? Then we will ask whether 676, is it smaller than 121?
No,
No,
sir.
it will not get updated. So at the end of the day, after comparing all of it, we will get one mean, right?
Yes, sir.
So after this, what we need to do? So we need to update the Z1
Outside
list.
of the, so it will happen outside the loop, right?
Yeah. For each, yes. So Z1 is equal to Z1 plus plus
Min.
Min.
min. Now we need to reset the mean, right?
Yes, sir.
Sorry. We'll need to reset the mean to 0. Now you have only one element in this. You still need rest of the element to be sorted. You also need to remove that element from the list 1.
So we also need to have a max value, don't we? So we also have to compare, because we can't remove 121 right now from the list. So we need to know that the next number we choose isn't 121 again, it should be 213.
Yeah. So the point here is, right, once it goes through all of the list, the min will be decided, right? So 121 was decided. Now we wanted to insert a process in such a way that whenever min, like whatever min comes, right, that has to be removed from the list, and then rest of the list should be put into a new list. This list has to be updated.
So,
Without
but we know we don't need to remove it. That would change the list 1. And we can just have a variable that each time we add a value of min, it will store whatever we added.
No, whatever we had.
So we can do after this adding thing, we can do now a new variable. Let's say it's a. Now a is equal to min. And in that condition, in the if condition, we can say that x should be greater than a and less than min.
So you need to have another set of if variable, right?
Sir, in that variable only we can.
So again, you have to do for each.
No,
X.
sir, no, sir, no, sir. We don't need to do that. We
Then.
can just, where you have written min is equal to 1000, we can have a is equal to 0. And then we can have in the if block, in the only if blocks we have, we can say that x is less than min and x is greater than a.
X is less than min and x is
greater than a.
And x is greater than, greater than a, and a has to be decided as 0. Okay. So if x is less than min and x is greater than 0, then min is equal to x.
Yes, sir. So after we add min, like we did 121, we got it. Now we added 121. So a will be 121. So when we go for 213, we will check that 213 is the minimum, but it's still greater than 121.
So a has to be what?
But not now, not now. In the end only. Just like this, the way it is.
So just let me go one by one, right? This is your full code?
No, we have to repeat this process again and again. So
you need to have another for each, right?
So this entire code will come under another for each.
Yeah, for each for?
for each y in list 1 we can have.
But you are not comparing y with anything else.
So,
Yeah.
In insertion sort, we have never calculated the value of minimum. I don't think this is how the insertion sort works.
Yeah. It has to be a comparison between the two. The insertion sort usually the
Yes, sir.
algorithm is you only compare the two and update the list for each two.
Adds each element in the new list and compares if it is greater than or less than and adds accordingly in the new list.
So what do you think your approach would be for this? Sorry. So in insertion sort, I think you should just go back and look at that insertion sort. Usually, there are so many ways a sorting algorithm work. In insertion sort, two elements are compared and the list is updated in each loop till whole list is sorted. Okay, so this is not from the exam point of view, but this is from conceptual point of view. This is such an important algorithm which you will encounter into later courses also, and there will be a lot of questions on this in interviews also. So when you look at the sorting mechanism itself, right, a good practice would be just go through this context and learn a bit more. So I'll just quickly go through with this. So you already know, just go through the sorted list insert algorithm, right, which sir has talked about. Apart from that, what other concept which we have covered in the list? Hello? Are there any more functions which we have talked about?
No, sir.
Okay. So let's go with the dictionaries. Can somebody tell me the definition of dictionary? What is the difference between the lists and dictionaries? Primary difference.
Dictionary has key and value.
Okay, how it is different than list? List, you said, right? List is a series of elements, right?
List we should have to go sequence wise, sir. We should have to check every.
So in our original list, right, in this concept, just take an example of this. Let's assume these are the test scores of some countries. Okay, highest test scores by some of the countries. So I am just storing into the list, but I am not storing the information regarding which country has maximum score in a particular test, right? But a list, like you guys said, that it has to go from one by one, right? You have to go iterate through all of this. The issue with the previous code which we had, right, we couldn't remove 121, right? Because every time we have to go from element 1 through all. So you need to manipulate list in such a way that you get the desired output. So difference between list and dictionary is, so suppose I want to create a dictionary, and let's suppose ABCD are the country names. So what is the standard format? Curly braces, then suppose A, then
A colon value of the score.
1 3, then B colon 654, then C colon
1 comma D colon 676 comma E colon
676
453
E colon 453 and F colon
876.
Do we need to put the double quotes to identify which is key and which is the value?
No, sir.
No, right? It is not required. So in this context, we know that
Inverted comma for A, B, C, D, and all.
We don't need to put commas also.
We need to put commas, but we need to put inverted comma for A, B, C, D. I mean key.
So the keys has to be in single
In
inverted
inverted.
comma,
Yes,
and
sir.
the value can be as is. So to distinguish between what is the key and what is the value, this is the way should go by, right? Okay, so how do you access a value? So what is the difference between, like we said, right? For list to access a particular value, say 121, we have to iterate from, you know, zeroth element or the first element. But in dictionary, we can directly access the 121 by by using its key, right?
Yes, sir.
Yes,
So
sir.
Yes, sir.
that is
Sir, but I have a doubt, sir.
sorry.
Sir, I have a doubt. In
Yeah,
the
yeah.
list, we can directly access any element through its index
In dictionary or list?
in list.
Yeah.
It's
So
possible to
yeah. Hello.
yeah,
Yeah. So can you come again? Your question?
yeah. My doubt is that in the list also we can randomly access the element
Yeah.
with the help of their index.
Like this list 3.
Means suppose the list 1 index 3 is the fourth element. So can we
Is
say that it is randomly accessible?
it is not randomly accessible. In list, the way usually works, right? You have to go from first element to second element to the third element to find it. Whereas in dictionary, when you say C, it is specifically directed to this value. So even if you say that, the list 3 in the actual computer memory or something, so it goes from 1 to 2 to 3, and then it will tell you what the value it is.
Yeah,
So
it
the difference,
basically it means in terms of computation, it is not randomly accessible.
it is not. The dictionary has that, is powerful in that sense. So in a lot of
Yes,
algorithms,
thank
you will see dictionary being used. Okay, so how do you access an element of a dictionary? Say I wanted to access element C.
by using its key.
DICT 1 C.
Keys are
And
B,
the name
C,
of the
So this will give me the value
1 to
121,
1.
1.
right? And this is also how in a lot of programming languages you might see they will define different elements to a dictionary. So a key usually go in here and the value comes after equals to. So what all functions which we saw, like how do you iterate through dictionary?
Using is key function.
So for
X in dictionary.
For each X in is key of something like that.
For each X in keys of dictionary.
just a minute.
Yes, sir.
Yeah, for each
X in keys dict1.
Yeah. So what is the data type of keys in here? Keys, right?
It gives us a list of all the keys.
Yeah. So when we say keys, DICT 1, sorry, this is a
Integer data type.
list of keys in dictionary 1, right? DICT 1, correct? So for each X in keys, then curly braces. So people should do they use it like this or do they use just by each X?
So just each X.
X in,
We can use anything we want, right?
sorry. Yeah, can you come again? Hello?
So we can use key or X, anything we want.
Yeah, anything you want. So in the X, we are being consistent, I think, is because we started with iterating through each of the cards, each of the columns, and then we kept on using the same. So it can be anything. So you may see that in case of Python, it will be usually, they will use whatever, in here you are using keys, right? They will just use key, each key in keys of DICT, something of that sort. Okay, so this is to iteration, right? Dictionary iteration. Next, what
So we
other
use is key, na, sir?
for each is key or
Is
just keys?
key for checking the value is for not or present or not.
No, can you come again? Hello?
Is key is used to check the value is present for or not.
Just a minute. So is key is to see whether a value is present or not. So that is for
Yes.
value check, right? To check if a value is present or not. Is key DICT one. So what should I say? See, if I want to see if C key is available or not. So should it be single inverted comma or double inverted comma in dictionary? What have you used in the course so far?
Single. If it is a character, then single inverted comma. If it's a string, then double inverted comma.
Good. So same way we can say if so if we had, suppose we had name instead of this, right? We had name like Alice, right? So in this scenario, for these two, it should be
double inverted
comma, right? Okay. And yeah, so the operation which we usually do for each X in keys DICT, then do something with the X, whatever it is, right? So it will, how do you access?
Write dictionary name, then a square bracket, and in the square bracket write X,
right? This is how we DICT one. So we do certain operations on this. How about is key?
Sir, we look for the key in the list of keys of dictionary. If we want to create a new dictionary with
Suppose
that,
if I want to use if, right? And I want to compare if the particular key is equal to something, how will I do?
Is key function returns either true or false.
So this will only give you Boolean variable, right?
Yes, sir. If C is present in dictionary 1, then it will return true, else false.
Or false.
Yes,
okay.
sir.
This is for checking the key. So that is why value check, right? So we see whether it is present or it is absent. So can you give me an example where we can use this to check whether a key is present or not?
Yes, sir.
So let's just take a look at those questions, right, which were asked in the beginning of the lecture, and see if these concepts encounter there, and we will see one by one how they
Yes, sir,
can be addressed.
move to that question, sir.
Yeah. So anything else apart from this we covered in dictionaries?
Sir, not key is also for the same, na, if it is present or not.
Just a minute. I'll just pull up the stop share. Yeah, what were the questions? Question number. So let's check mock quiz. Mock quiz was discussed, right?
Yeah, yesterday also.
Week 5, week 6, and then the mock quiz. Any other questions? So I will go with the week 6 is still the list, right?
Sir?
Yes, sir.
Okay. Let's look at an example of list, and then we will look at an example for dictionaries. Let me share this question. So is the screen visible?
Yeah.
Okay.
Yes, sir, visible.
So grade assignment 6, what was the question query in here? Question number. Question number 9, 10, and 11. Practice assignment week 6. Yeah. Nine, 10. Where is 11? Danya, is this the query you had? 9, 10 question. Not graded assignment, practice assignment. No? Question number 9. Okay, 9 through 11. Yeah, let's take a look at this. We take the variable outlist obtained at the end of the execution of the pseudocode in the previous question. Now we execute the following pseudocode. Take the variable outlist obtained at the end of the execution of the. So what was this outlist doing? The following pseudocode is executed using words dataset. Assume that the rows in the table are sorted in the ascending order of sequence number. So we have start is equal to true. Just a minute. Yeah.
Your screen is not visible.
Just a minute. I'm sharing. Yeah, both the screens are visible now, right?
Yes, sir.
Okay. Do you guys have any question from week 7 and week 8 regarding the dictionaries? So we'll take one question from here, which is I think lists question, and one question from the dictionaries. That is week 7 and week 8.
Yes. In week 7,
Yeah. Your voice is breaking. Can you put it here?
Questions from practice assignment week 7.
Yeah, practice assignment.
Hello.
Yeah. Hello.
Sir.
Yeah, your voice
Am I
is
audible?
Yeah, can you put it in the chat because I'm unable to hear you clearly. Your voice is breaking.
Is it now? Is it fine now, sir?
It is better now. Yeah.
Yeah, sir. I have hello.
Yeah, go ahead. Hello.
Hello, sir. Is it
Yeah.
good now?
Yeah, it is fine. Yeah.
Okay. Yes, sir. I have questions from week 7 and week 8. Primarily from week 7 practice assignment.
Number?
5, 6, 8, 9, and 10.
Okay. And week 8?
Sir, from week 8, I have in activity question point 2, question number 4. In activity question point 3 and point 5, in both of them, I have question number 2. And
1 minute.
practice assignment week.
Week 8 activity question.
Week 8.
9 to 11.
Yeah. Danya, I will discuss that. Let me just note it down. Week 8 activity question.
Point 2, question number 4.
2, 4.
Point 3 and point 5, question number 2. And practice assignment of week 8, question number 2, 4, and 5.
Okay. This is week 8 now. Okay. So let's go with this week 6 assignment. Then we'll go to week 7 and week 8. Okay. So question number 9 to 11. Danya? Yeah. I think this was. So what does the outlist do? Just a minute. Question number 6, 7, 8. The following pseudocode is executed using word dataset. Assume that the rows in the table are sorted in ascending order of sequence number. The rows in the ascending order. Okay. So we goes on words data set and then ascending order numbers. Okay. Yes. So we are looking at practice assignment 6, question number 9 through 11, but we need to look at the question number 7 and 8 because 9 and 11 talks about outlist obtained from the question number 7 and 8. Okay. So yeah, the following. Yeah. So we have a code which does start is equal to 2, outlist is empty, while table 1 has more rows. We read first row. If start is true, then enlist is equal to empty and start is equal to false. Then enlist is equal to enlist plus plus x dot words and x dot part of speech. So and then sorry. At the end of the execution, which of the following statements are true about the variable outlist? Okay. So we take the variable outlist obtained at the end of the execution of the pseudocode in the previous question. Now we execute the following code. So we have just analyze this one. So I'll just bring out the words data set. Just give me a minute. Yeah, okay, this is your words data set, and now we have star is equal to true, outlist is an empty list, while table 1 has more rows. Read the first row, x in table 1. Now start variable is assigned true value, right? So for the first element, right? So for the first, which is it, right? It was Monday morning. Swaminathan was reluctant. So it was Monday morning. So we have what? For the first element, the start is true, right? It will go in the in list and it will form an empty in list, right? And then it will put start to false. Then at the end of it, in list is equal to so what is x dot word? It and x dot part of speech. So we have it and pronoun, right? Yeah, it and correct. So if x dot word ends with a full stop, outlist is equal to outlist plus plus in list. Start is equal to true. So does the it word ends with a full stop? No, right? So it will not go in here. So it will again go to the next element in it, right? Now start is false, right? So it will not enter into this loop. It will go and it will put x dot word and x dot part of speech into this in list, right? So we have an in list. Sorry. So the next set will be was and verb, right?
Yeah.
Verb. Then it will keep on going. It will keep on. So it doesn't work with. It doesn't end with full stop. So it will skip this again. It will go to the next one. So it was Monday, right?
Yeah.
Part of speech. Noun.
Noun, sir.
Noun, right? Monday and morning is also noun. Sorry.
It's a background.
Noun. And then morning, it was Monday. And then in the next case, right, you have morning, right? And the morning word itself ends with a full stop. So before that, it will also execute this, right? It was Monday morning, and it is also noun. So you have, and then it stops with the full stop. Then outlist is equal to, so outlist, which was empty before, will become what? In list, right?
Yes.
So whatever in list it was here will become an outlist. So an outlist contains what? Sentences. Each element in the outlist corresponds to one sentence from the paragraph. Sorry. Okay. So that is what it is. So it is saying that we take the variable outlist obtained at the end of the execution of the pseudocode in the previous question. Now we execute the following pseudocode. So what is the pseudocode? So now you have somewhere is 0, count is equal to 0, I is equal to 0 for each x in outlist. Okay. Somewhere is equal to somewhere plus length of x. So somewhere is 0, right? Somewhere is defined 0. And then for each in outlist, right? So it is, so what was the last statement?
Monday morning.
It was Monday morning. It will go through all of this, right? And it will go at the end till a thin long cane.
Okay.
Right? The last of it will have that. So what it is doing somewhere, for each of the element X in the out list. So what is X in the out list? Sorry, repetitive. Yeah, so each one has set of 2, right? List. So for each X in out list, so for this example, right, it and pronoun will be X. X is equal to this, right? Somewhere plus length of X. So what is the length of X?
2.
Right? So LNGTH of X. In this scenario, it is 2, right?
Yeah.
Although somewhere will become 2. Here somewhere. For this instance, it is 2. For each Y in X. So for each X in the outer. So again, it is going inside this state, right? So your first Y is 8, right? So Y is equal to 8. If last Y is equal to noun, count is equal to count plus 1, right? So unless and until the second one is not a noun, it will not count, right? Your count variable. So your count variable stores the information of noun. For each Y in X, right? And what does I stores? The information of, so I is essentially out of this loop, right? For each loop of Y. So it is in the X. So all the elements in your X, the original out list, right? So for each X, I will be incremented. Correct? The number of correct? So what does the count variable stores at the end of the execution? The number of nouns in the paragraph. Shows the information on the noun. Yeah. So that is what it is. Yeah. What was your question in here? Hello? Hello, Danya. Is the answer clear to you people?
Yeah.
For this? Right? Why it
Yes,
will
sir.
only count the nouns, right? And you
Yes,
have
sir.
whole paragraph in which the noun is being counted. And then what was 9? Number 10 was, what does the somewhere stores at the end of the execution? So somewhere was storing what? 2, right? The total number of elements in X. Right? It is the number of words in the paragraph. Okay.
Sir, can you explain few questions from practice assignment of week 8?
Yeah, we will look at the week 8 also. Okay, I'm just asking Danya what was her query in this question. So the first question was correct. So the second one was what? Somewhere. Somewhere we are counting somewhere plus length of X. Yeah. So for each X in out list, the length of X. The number of words in the paragraph, the number of sentences in the paragraph, the number of characters in the paragraph, none of the above. This is the number of words in the paragraph. So this length of X, right? This variable, what does it store?
Count.
No, count of what? Count of these elements, right? 1 and 2.
The number of words in a sentence.
No. In this, if you look at, right, for each X in the outlist, right? When you look at the outlist is made up of two elements, right? One has word and one has X dot part of speech, right?
Yes, sir.
So each of the X will have two elements in it, right?
Yeah.
So this is 2, this is 2, this is 2. Each of them will be 2, right?
Yeah, okay, sir.
So for each element in X, it will increment it by 2, right? Or 1.
Sir, if we consider X as a pair, then it will be counted as 1.
X is the sentence elements of outlist are sentences and not words in a sentence.
Outlist, if you look at it, right? So enlist becomes outlist, right? In here,
Yes, sir.
your enlist is constructed from X dot words and X dot part of speech, right?
Yes.
So it is not just the words which are the part of your enlist, right? So your outlist is essentially just the enlist when when it encounters a full stop.
Oh, okay.
So when you iterate over each of the X here, each of the X in the outlist, when you look at the outlist, when we say each of the X, this becomes X, right? And then inside elements will become your Y's. So why it makes sense that, what count is actually counting. All the number of nouns in the paragraph present will be counted in here. But when we say that somewhere is storing the number of words, it depends, the answer depends on this function, length of X. So that's why I'm asking, what does the length of X gives you in lists?
Sir, here given that the if last y is equals to noun.
Hmm?
In a question that if last y is equals to noun.
If last Y is equal to noun,
Yeah.
then count
Is equals to count plus 1.
Okay,
or
because in here your Y
in X.
is your entire list, right? This full list.
Yeah.
So this is usually a
Means
list of list, right? We have 1.
Yes.
Yeah, okay.
Right? 2.
Yeah.
So this is for one sentence, then next one will be for another sentence, right?
Okay, okay.
So which is why it is actually counting the number of words in that sense. So each one will become one single word in this scenario.
Okay.
That's fair.
Yeah, no.
You're very good to catch that. Last Y. Because if you look at this, then you again go back to your old code. And in here, you see that it is executing for all of the sentences in the commons data set. And each of the sentence is a list in itself with a list of words plus part of speech as a part of it. Okay.
Yeah, okay, sir. Now.
And what was the question number 11? Which of the following statement are true about the variable I at the end of the execution? Yeah, so we saw what was I? Stores the information of the number of elements of the outlist. So it equals to the length of the outlist. It equals to the number of elements in the outlist. It is the number of sentences in the paragraph. All three make sense, right? Hello?
Yes, sir.
Okay, so we will go to week 7. Was it? Week 7 practice assignment?
Yes, sir.
No, what was that? Practice assignment, question number 5. Yeah. The following pseudocode is executed using library dataset. What will D represent at the end of the execution? Okay. You have an empty dictionary which is coming in. Then while table 1 has more rows, this is on library dataset, right? Just let me pull that up. Okay, you have rows, names, author, genre, languages, pages, publisher, years. Okay. While table 1 has more rows, read the first row X if is key D X author. So what does is key do? It tells you true or false, right? Is key.
Yes, sir.
Then it is operating on D and X dot author. So that means if in a dictionary D, X dot author is present or not. If is key,
No,
and
sir.
then if D of X dot author is greater than X dot year. So let's look at this. Okay. Let's look at the first one. So D is an empty list. So we take the first one. So suppose igniting mind this. So your first author is Kalam. Number of pages was there, no? 178. Yeah. No, X dot year was there. So is key will give you what? True or false. Tell me what if D X dot author is greater than. Yeah. So yeah, what does D of yeah, this stores what? Yeah, D, so it will store for the first row, right? Kalam. And X dot my year is what? 2002. Okay. Yeah. So while table 1 has some rows, read the first row X in column. If is D, so let's look at it. Is key D and X dot author. So what will be your first author? Kalam, right? Your first author is Kalam. Is it
Yes,
present
sir.
in the D? It is not present, right?
No, sir.
So it will get out of this if loop, right? Then it will go to else, right? And in else, it will assign X dot author is equal to X dot year. So your D X dot author, this key will be assigned to X dot year. So in terms of D dictionary, how it will be? So you have Kalam, sorry, colon 2002, right? This becomes your first key. Then we are moving the X from table 2, right? So we will go to the next column. What was the next column? Let's look at the last column. Yeah. So now we will look at whether in your dictionary, what? Is X dot author Narayanan? No, right? So if is key D and Narayanan is not there, the key Narayanan is not there, again it will skip all of this, it will go else and get into, it will add it, right? Now you have Narayan or Narayanan? And it is year
I think
Narayan is 1943. 1943, right? So essentially it will keep on going from this loop till it finds the same author, right? If suppose I have another book of Kalam, right? It is not there. Suppose Kalam wrote a book in 2005, right? In this scenario, if is key DX author, it is true, right? Kalam is present for this particular set of data. So if if D X dot author is greater than X dot year, it is true, right? It is from 2005, not 2002. So then D X dot author will become X dot year. So again, you will add it to this, or it will update the original key.
update.
So it will update.
Updates. So you will have a list, right? Here now,
Yeah.
right? Then the next one will be 2005. Same way, what if it goes from 2001? Say Kalam wrote a book in 2001. Read the first row X. If D
Sir,
Kalam
why
is there.
do updates, sir? Sir, I think they replaced 2002 and made it 2005, sir. They not appended, sir.
Because it is assigning the new key. What is the way to append into the current directory then?
Sir, if plus sign here, then we append, na, sir.
So it will be what?
Replace 2002 by 2005.
It will be 2005. So what it is essentially do is it is looking for whether a particular author exists and if it has published the latest one or not, right? That is what it is doing there. If that author is not in the dictionary, it is being updating that till all of the list is executed. So the question is, what D will represent at the end of the execution? So directory, the dictionary of, what is that? Dictionary with authors as key. Let's just check. So what do you think the answer is among these three? So it is dictionary with authors. All of that is true as keys map to the year of publication in all of that, of their latest book, of their first book, of their second book, or of their second latest book. So it will be latest book, right?
So the correct answer they're giving is the first book.
Wait a minute. Huh?
B.
What? B is answer. Where is that? This one, right?
Yes.
Yeah. Two. The answer is not the latest book. It is their first book. So if Dex, let's look at our code, right? What we did. So we had Kalam in 2002. Then we said that what if he had a book in 2005? If D X dot author is greater than X dot year, D X dot author was 2002. Is it greater than X dot year 2005? No, right? So it should have been 2002 itself. It shouldn't have been 2000. Sorry, 5. Only if it had been 2001, maybe in that sense. Suppose we have this condition, then 2002 is greater than 2001. If so, then it will update that. Okay. So it won't be the latest, it is the first book. Sorry, try to put it in the chat. I am unable to hear what you're trying to say.
Clear, sir.
Yeah. No, somebody was trying to speak. It was not clear what they are trying to say. Yeah.
So
So
the last part, like why is the answer first book.
So let's say Kalam has
Because-
published books in, no, see, if it is generating list, right? Then it's the question itself, the answers, the list of answers which you see, right, doesn't make any sense. But if you have Kalam sir has, have published books in suppose 1995, 2001, then 2005, 2006. Suppose we start with 2006 was the first entry in our case. Okay, so the x dot year. So first of all, we never had the dictionary is empty. The first author is Kalam. He published book in 2006 because there is nothing in the no entry is in the dictionary. It will update it, right? So the update will be what? Kalam and 2006 in this case. Okay. Now we will go to 2005. Okay. While then again, if the next row is again Kalam with the publication in 2005, it will ask whether that author exists or not. It exists. Okay. Then it is asking whether the value mapped to the author is greater than x dot year of the current, right? So is 2006 greater than 2005? So just
Yes, sir.
click it down. Okay. So now you have 2005 as the new entry. Is it greater than 2006? Right? It is yes, right? Or no?
No, sir.
Oh, sorry. It is 6. And the new value was 2005, right? We are going
Yes,
in this direction, right? So we are looking at 2006 is greater than 2005. That is true. Then it will go inside. Now it will say that what you should do, that author's key should be replaced by x dot year. So the current x dot year is 2005, right? So it will get
2006. We will replace it by 2005.
Next will be 2002. Again, the same comparison will come where it will ask whether 2005 is greater than 2001.
2001.
If it is true, then again it will replace that to 2001. It will keep on doing that till it reaches the
1995.
oldest one, right? In our list, it is the oldest one is 1995, right? So
Yes, sir.
it is giving you the year of publication of their first book in the list of library dataset. Is the answer clear?
Yes, sir.
Okay.
Yes, sir.
Number 6 was also there. Consider the dictionary D created in the previous question. What A represent at the end of the execution? A is equal to 0 for each key K in keys D. So we are looking at each of the key. If D of K is greater than A, then A is equal to, so let's look at that. So you have a counter, A is equal to 0. Then for each K in keys D. Okay. So tell me the first key. Right now we have Kalam and Narayan, right? So we'll say Kalam. If D of K, so what should it give? D of Kalam is 1995, right? The value?
Yes, sir.
So is 1995. Is it greater than, is 1995, sorry, 95 greater than A, which is 0, which is true, right?
Yeah.
Then what it is saying, A is equal to D of K, which is 1995, right?
Publication year of the first.
Yes, sir.
So it will keep on doing for all of the keys present in it. So the essential thing is that now your new A is 1995, right? 95. Okay. Now we are looking at the next key, which is Narayan, which is 1990, 1943. So let's look at this. So is the condition true? Is 1943 greater than 1995?
No.
No, right? Then it will exit. Then again it will go to the next key till it finds the latest one, right? The most recent book published in the directory. So what is the answer? So publication year of the most recent book, which is also the first book of an author. Yeah, so we already established that what it stores is the first book, right? In the dictionary. So all the authors, so there will be only in one instance of the author, right, in the dictionary, with the first book published. So the publication year of the most recent book, which is also the first book of an author, right? That should be the answer, right?
Yes, sir.
Is that clear? Whose question was this?
Well, can you repeat the last part and understand how come the recent one and the most recent one and the first one of the
So the most recent one is, you take a look at this, okay? So suppose you have one more instance here, say Premchand in, say 1856 or something, or say 1925. Then we have another one, say Tilak,
Burma.
let's say 1915. Verma, sorry, say it was from 2007. Okay, so now if you look at your value, right, for each of the instance, what we are trying to compare is the previous value of the key is greater than the newer value of the key, right? So first we had a was 0, right? So we looked at whether 0 was greater than 1995, right? So it
Yes, sir.
was that, then we assigned a to 1995, so we became 1995. So next value, the next author, right? So because each of the author has only one entry, right? Next will be Narayan, so we will say okay, 1943. So we'll ask whether 1995 is greater than 1943.
Yes, sir.
Right? So
Yes.
if it is so, then what do you call? So we started with 0, then it becomes 1995. A
So
became
we
1995.
so we keep going on and check whether the year is greater than or not. If the year is greater, we update the dictionary.
Yes, yes.
And
so
then and from that we can say that it is the most latest book of this author.
yeah, so it is the recent book of the author. That is correct. But we also looked at what the dictionary stores, right? It stores the first book of the author, right? In the previous one, you
Yes.
saw that it is their first book, right?
Yes, sir.
So the publication year of the most recent book, which is also the first book of an author. That is correct, right?
Yes, sir.
Well, that is why
Okay,
that
sir.
answer is there. Okay.
Got it.
Okay. Then question number 7 was also the part of it.
Sir, I have doubt in such
No,
previous.
sir, it was question number 8.
8. Yeah. Consider the dictionary city D created in previous question. Okay. What will A and B represent at the end of the execution? So city D is
Sir,
created.
in this I have doubt with the fact that how come male student has scored highest, not more than the female in physics.
So I need to look at both. Okay, let's look at the pseudocode. Which CTDK represent at the end of the execution. So you have an empty dictionary called CTD. Okay. So we are looking at scores dataset, right? Scores dataset. Yeah, this is your scores dataset. You have name, gender, date of birth, city, town, mathematics, chemistry, total. So here we are looking at city. Yeah, so each key does what again? Each key will tell you whether it is
Present or not.
of the dictionary, if that key is the part of that dictionary or not. So it will give you only true and false, right? True false. So it is looking for is key ctd is your directory, is your dictionary, and x dot town or x dot city. Okay. So town or city is your second. Okay, city town. That's how they have represented it. So yeah. So initially your your dictionary was empty, right? So this it will not get into this, right? In the first if loop, if is key ctd or the second one or the third one or the fourth one, it will not get into this else because this else is linked to this if, right? And then this else is linked to this if. So if this is not true, then we are assigning ctd. So what will be the first element of ctd? So ctd says put town and gender into physics mark, right? So yeah, can you tell me the first instance of town and city?
Erode.
So erode. Should I put it like this? Erode?
Yeah.
Yes, sir. And then call. Yeah.
Then M.
Then
Gender.
Salim.
Name or gender? Was it?
It was gender.
So M.
Gender is M, and then the marks are 64.
64. Physics marks. Okay.
Yes, sir.
64. Okay. Can you just let's do for the second one also. What is the second one?
Salim is the city name.
Salim.
Male is the gender. And 45 are the marks.
So 45 are the marks. Yeah. Just a minute. Huh? Yeah, the syllabus is from week 5 to week 8. Okay.
For quiz 2.
Yeah, yeah.
Okay.
Yeah.
Only 5 to 8, no?
Sorry?
Only 5 to 8, right?
Yeah. Only 5 to 8. So we are essentially only covering these two concepts. Yeah. So back to the question. Okay. So it says that if is key ctd x town, if it is, then it will go again. So it will keep on going till it will find erode, right?
Yes, sir.
Or will it find for 64? If you look at this, right, ctd x dot town is again. So let's look at that. I think in here it is saying that ctd x dot town.
So it will check if the person from erode and with the same gender has whether less marks than the first one.
Yeah, no, but if you look at this, right, it will keep on going till you find the erode city, right, in your data.
Yes, sir.
So if you look at the erode, another instance of erode, there is no another erode instance.
No
right?
other erode.
So again, it will move to the next one.
Sir, 18 number.
Yes.
18. Okay, yeah, there it is. Okay. Okay, Abhirami. Okay. Then it will compare the marks. Let's look
Physics
at
marks with the Abhirami.
Let's look at the. Yeah. So in that scenario, is key ctd? Yeah, that is true. Is key ctd? You have erode, right? Then it will go.
Yes.
Okay. Is key into is key ctd, and then the gender. So it will look at both the genders, right? But gender is different, right? In this scenario.
Yes, the gender is different.
So in this scenario, it will update the gender and it will update the marks also, right? Again,
Yes,
we
sir.
don't have another instance of the same, right? Where the it is from erode and is male or female now.
It's a female.
So
No,
there
right?
doesn't seem to be any.
So let's take, for example, I think Chennai has more
Yeah, Chennai has more
such.
number.
So let's check. So in the first check, what it did, it looked for whether it is Chennai. Okay, in
Yes.
your in your dictionary, you have Chennai or not. If so, then if the gender is the same or not, right?
Yes, sir.
The city and the gender. If both are same, then you look at if the physics marks, right? If x dot
Yes, sir.
physics, and so suppose you have a case where, yeah, in
Shout
this
out
case, right,
Chennai.
you have this Chennai instance and in this Chennai instance where both are female, and you have the condition where you can look at the marks, right? If the physics marks is bigger or smaller. So where is it? This is the one, and 53 and
92 is for Akashya and Ritika is Ridya is 55.
yeah. So it says whether the current. So first instance was 55, right? Is less than x dot physics, which is 95, right?
Yes, sir.
Then it is asking you to update the highest mark, right?
Yes,
So
sir.
the gender has to be same. Among the gender, the x dot physics highest mark is what it is being looking at, right? Using this loop.
But sir, in options they're asking between different genders.
So this is for one gender. Then else this is for another gender. So there are two values gender can take, right?
Okay.
So it can also be for male as well as it can be also for female.
Female.
For both of them, it will report the highest mark.
Okay.
So what is the answer?
With the highest physics marks by gender that in city key.
So a dictionary with gender as key map to highest physics mark scored by that gender in city K.
City key.
Yeah, that is true, right?
Yes, sir.
Okay, and that was your question, right? How?
No, question was 8.
8. Okay. Consider the dictionary.
Sir, I
Sorry.
have singled out in preview, sir. Can I share my screen?
No. Can you tell me what your doubt is?
Sir, there is a question, sir. So I want to share my screen or link, sir, of PYQ question. Then you open your computer.
Yeah, share the link.
Okay, sir.
Okay. Yeah. So let's look at this question number 8. Consider the dictionary CDD created in previous question. What A and B represent at the end of the execution? Okay. For the person who asked for the information regarding the procedure, right, I would really ask them to look at the quiz 1 review session. There you will get the information regarding what the procedure is. Okay.
I share the link, sir.
Let it open. Let's just look at this first. Yeah, what question number?
8.
Question number, sir, 55.
Okay, so
Question number 55. Yeah, question number 55. First LB. So what is this lead question? Choose the correct statements based on the following pseudocode. Okay, it's a list comprehension. Yeah, what is your question? Let me just quickly share it. Okay.
Hello, sir.
Yeah, just a minute. I'll just share the screen. Yeah, this is the question, right? Is everyone able to see it?
Yes, sir.
Question
Sir,
number
question
55.
number 55, sir.
Yeah, but the lead question is this one, na? Choose the correct statements based on the following pseudocode. your list 1 is 1 2 3 4 2 3 4 3 4 5 4 5 5 and then empty. Then LB is empty list, LC is empty list for each A in LA. So what is your first A is 1 2 3 4 5, right?
Yes, sir.
Then LB is equal to A plus LB. So what's your A? A is your first list, right? So you're prepending the list. For each B in A, LC is equal to LC plus B. So for each element in B, right? So first element in A will be 1, then 2, then 3, and then 4. So it will keep on appending into LC. So it will be 1 2 3 4. And it will be, in this scenario, just 1 2 3 4, right? So LB and LC are both same. In the next iteration, then A will become 2 3 4. So the question number 55 is,
Sir, I have also doubt in this question. Can you tell me what is the length of LC, sir?
LC is 0 right now, right?
No, sir, after appending the list, sir.
So let's just go one by one. Okay, just a minute. Okay, so yeah, so your LA you already have, LB you already have. Now we will see for the first element, LB becomes is equal to 1 2 3 and 4. But you have to understand that we are prepending. Okay, anything in the next iteration will come before that. And LC, in this we are doing what? Again, we are iterating through each of the element of A, and then we are just printing 3 4, right? And whatever will come, we are appending it, right? That is what it is doing, right? It is appending in here all the
Yes.
new element which is coming in. So now in the second iteration for next A is 2 3 4, right? So 2 3 4 will get appended to this, prepended to this list, right? So you will have, next one will be, correct?
Yes, sir.
And then for the LC, for each B in A, so that is your 2 3 4, LC is equal to LC plus B. So now you have to append to this list. So it will append inside or outside?
Inside, sir.
And what about LB? Should be inside or outside?
Outside.
So because it is dealing with each of the element and each of the element is single. So 4, then the next one will be B. What is your first B? 2, 3, and 4. Then
Sir, I have doubt, sir. Why LB appending outside and LC appending inside, sir?
let's ask this question. Okay, so when you say A in LA, right, and your LA is a list of list. Okay, so you have 1 2 3 4, then 2 3 and 4. Okay, let's just take with this example. Okay, so your A is what? Is the entire list, right?
Yes, sir.
So list, you're prepending a list and you're appending a list, or you're what do you call an element? How do you append an element and how do you append a list? In this case, right, a whole list is an element, right?
Yes, sir.
So when you append it, it will append it as a element or as a individual element? Hello?
Sir,
See,
including which list, sir?
huh?
As a list, sir.
So it will append this whole set as one element, right?
Yes, sir.
So that is why when you do plus plus LB, right, in this scenario, right, what it is doing, it is appending the whole element. So it is not considering it as a list. This is a part of the element which will be prepended in here. While in this case, you are looking at each of the element into this list, right? And that is being appended to your current list, right?
Yes,
So
sir.
each of the element will be 2, 3, 4 will be put in the LC. So does that answer your question here?
Yes, sir.
Okay. So should I just close this?
Sir, how sir first of LB is the empty list, sir?
Sorry? How?
Sir, how? Sir, question number 55, sir.
Okay, question number 55. First, what was that question? Choose the correct statements based on the following pseudocode. Answer the given sub questions. Is length of LA equal to length of LC? If first of LB is equal to empty. So what is your LB? LB you are prepending, right? You're prepending each of the element from the LA list. What is your last element?
Sir, empty list, sir.
So will the empty list will become your first element of LB because you are prepending it, right? So in first operation, you put this one. After this, it will come. Then next will be what? Do you understand or should I continue? So or it will be 3, 4, and 5. The next set will be 4 and 5. Right? In the next iteration, it will be just 5, right? And in it, the first element will be empty. Does it
Yes,
make any sense?
now understand. Yes, sir.
Okay.
Thank you, sir.
Because you were prepending it. Okay. Yeah. Week 8, we just looked at week 8 or week 7? In
So
week
week
7.
7 was going on right now.
Okay.
We are going through the practice assignment question number 7.
Yeah.
Week 7. Sorry, week 8. Question number 8.
8, right? This one.
Yes. Sir.
Yes. Okay. So now that we know what that list was doing, consider the dictionary CTD created in previous question. What A and B represent at the end of the execution? Dictionary CTD created. Okay. So we know what the dictionary contains. Gender as key map to the highest physics marks scored by the gender in the city, K. So what A and B represents at the end. So we see A is counting something, B is counting something, and you have two if conditionals, and there is one superseding if conditional. So this if, this else is a part of this if, right? So
yes,
we'll
sir.
look at it for each I in city D. So suppose this is the scenario which we already have. City D, I in keys of city D, L is equal to keys of. So again, what we are defining here, L is list, right? List
Yes,
of
sir.
keys, right? So it will have all the information of cities, or it should have
Yes.
so the first element, right? I. So city. So say A Road, Salem, Chennai, and so on, right? If
Yes, sir.
first L is equal to M. So, but you said that city for each I in keys of CTD.
CTD.
So you have more than one key, right? In city,
Yes,
you
sir.
have A Road as well as you have M,
M.
right? Whether so your L should have a list of lists, right?
Yes, sir.
So you have M. Suppose you have M. Yeah. Something like this, right?
Yeah.
Yes, sir. So here actually we have a dictionary with the like list and list with list and list format. and it's checking with for the first element in the L. So if the first element in the list L is M, then it's going further. So I guess it should be M comma erode.
First element of L. See, L is keys into city D of I. So you have two instances of I, right? In L, right?
Yes, sir.
If you look at your keys of city DI, so you tell me what the values of this will be first. Keys of city D. Hello? Yeah.
Yes, sir.
So what will the value of this? What does keys gives you? Keys gives you list. But
list, yes, sir.
now if you are saying that city D of I, it has two elements in it, right?
Yeah.
How many elements does it?
Yes, sir.
Two.
Two elements will be there in list L.
In keys, right? There should be two.
Yes. Yes, sir.
So I will be 1 and 2.
Yes, sir.
Sure. Hello.
Yes, sir.
Are you sure?
Yes, sir.
So look at this again. Okay. You have city D, which is an empty dictionary. Yeah. Which is being defined. Okay. You're looking at city. Sorry, where did it go? Yeah. And then you have another one, which is storing the information of gender as well as x.physics. So consider this A and B represent the execution. If first of L is equal to M, but first of L, how it is M?
I guess it's storing gender first rather than
Where?
city
If you
name.
look at it, right? Do you see it is storing gender first?
No.
What does first tells you?
First is town or city name.
No.
In first of list is town or city name.
Yes, sir.
First element, right?
Yes, sir.
Okay. First of L is first element. So you have a list of list. If first of L is equal to M, will this condition satisfy?
Yeah.
No.
No,
It
right?
won't. According to this, it won't.
So if whatever we are saying is true, this should not be get executed, right?
Will be last of
Yes,
L
sir.
is M.
Sorry?
Last of L D.
First, last.
Yeah, last of L should be M, right? Not first of L. So then it should go to else block, right? What is the else block? If city D I, which can be, it is iterating over both, okay? So suppose in this scenario, if I look at for each key, for each I in keys. So let's again break it down further. Okay. Tell me what keys this will give me. Keys city D is equal to what?
City name and gender.
City
Yes,
names.
city name. Yes, the city.
City name. City name and gender both.
Only city names, sir.
Only city name.
Then what does this mean? So how do you call a key? We call a key by city D and then the key name, right? Key.
Yes, sir.
Call upon value. Okay. So it is
Yes,
calling
sir.
upon a value of I. So what
Yes,
does
sir.
this should contain now? Again, let me ask you. So even if we say that it has both the information of town and gender, which is something like this, right? Sorry. Yeah. Should it give you something like this? Or just is equal to erode Salem? Or should it be only M, and F? Which one is it? You clearly are assigning here two keys, right?
Yes, sir.
Yeah, choose.
Yeah. So everyone agrees this is the answer.
Yeah.
So what will be the I? First
I,
instance of, if suppose I is equal to 1. What is the value of L?
Erode, comma, M.
Erode, comma, M.
Okay. So what is the first of L?
Erode.
Erode.
Yes.
Erode.
Erode. Can it go to the next and check whether it is M? Not possible, right?
No, sir.
So if first of L is equal to M, it is not going in, right? We are not even thinking
Yes.
about this at all. If
Yes, sir.
the C flow, then we enter into else flow, if that is not the case. Now answer me, if city DI, what is I here?
Erode.
Only erode?
I is the first element.
City.
M.
Yeah. So what is your first element?
Erode.
Erode.
Erode and M, right?
Yes,
Yeah.
sir.
Yes, sir.
Yes, sir.
That is one element, right? This is one element. This is one of the
Yes, sir.
element. So in this, what is your first of L?
Erode.
Erode.
Erode. Okay. So you have erode. Sorry. So first of all, it is asking you d of I, which is the whole thing, then erode of it. Is it greater than city I? Again the same.
Salem.
And the last of L. So that is M.
Salem,
And
comma, F, and yeah, Salem.
Sorry?
Sir, how is it erode?
M, sir.
See, again, for each I in keys in D, right? So for your
Yes,
first
sir.
of I is already decided what it is, right?
Yes,
For
sir.
this I, you are going in. So if you go that, if that is your I, what do you think the information about L will be?
Erode, comma, M.
L will be part of this whole thing, right?
Yes, sir.
Where is it? Yeah, so L is essentially all the keys in the dictionary, right?
Yes, sir.
Or it is only for the first one?
No, L is all the keys in the dictionary.
Sure, because then why it is calling it I? Sorry.
Sir, unless and until we enter a value in the I, it will be all the keys for the dictionary, right?
Yeah, suppose
So
for
it-
each I in the keys,
for
I
each
say,
I, if okay,
suppose
so
my I is erode. Okay, let's just take my I is not 1. It is actually keys, right? My
yes,
first is erode and M, my first key. That is what it should be, right?
yes, sir.
Or erode and F, maybe the other part. If you have
Yeah.
email with erode who have that marks, right? It can be either
Yes,
or, right? So your I is either this or that in city keys. Okay, if that is the case, what is the value? What is the L?
L can be erode or L will
No,
be
no,
erode.
right? You are saying that keys into city D. You're asking the same thing, right? Erode,
Yes, sir.
comma M, right?
Yes, sir.
So what does this information should give you? What is the output of this?
Erode comma M.
Right?
Yes, sir.
So because that is the only key, right? It is only
Yes, sir.
asking for us the specific key in that
Yes, sir.
specific key. So all L is doing is just storing erode comma L,
Yes, sir.
right? In the first instances. So L is just storing the value of I, is it right?
Yes, sir.
Okay. If first of L is equal to M, first of L is M.
No, sir.
So we can't go in this, right? But even if that is the case, we again still have the same issue, right? We have erode M, and again you're asking for M, last of
Yes.
L, right? Is
First of
greater
L is
than, again, the first of L is your erode, is greater than
erode.
city D, again erode and M, and we are asking
Yes.
whether then it is M, right?
Yes, sir.
If this is bigger than B is equal to B plus 1, what is it trying to count? So I think the understanding of how actually the data is being stored in this particular scenario, right? How the keys are being stored is I think what we are missing. Because unless and until it doesn't give you either M or it doesn't give you something which can talk about whatever being mentioned in this option, what A and B doesn't make any sense, right? It should just be, there
Yes.
should be an option that it doesn't make any sense at all.
Yes, sir.
But we clearly see that we have 4 options. What are the 4 options? We have number of cities from which male student has scored the highest physics marks than female. Number of students. So we already know what a dictionary maps, right? The gender, the dictionary with gender as a key mapped to the highest physics marks scored by that gender in city K. Okay. So if this is the answer, we are saying that the gender as a key is mapped to the highest physics mark by that gender in a particular city. So based on that, number of cities, number of male students, number of cities, number of female students. So you have two options which talks about cities, 2 options which talks about students. So in any of the scenario, tell me what information is being stored in this dictionary. It is stores about the highest physics marks scored by a gender.
Yes,
right?
sir.
It can be male or it can be female. So can A and B be the number of cities?
Yes, sir.
And can A and B be number of male students and female students also?
Yes, sir.
Okay. So just take a look at it, okay? Again, one more time.
So actually
The
here
second
they are
option
saying
waste
that
number
gender is being stored in the previous answer.
Yeah.
In the previous question, in the answer they are saying gender is as the highest mark scored by a gender in city K. So here we can say that
the gender is used as a key to map the highest marks.
Yes, sir.
So does the number of female and male students in second option mean the second element in the list? Does it
Sorry?
refer to the second element in the list? Number of male and female students.
So if you look
So
at,
does the number of male and female students refer to the second element in the list?
can you come again? There is a lot of background noise. Yeah, number of
So does the second option indicate the second element of the list?
This one.
Yes.
Number of male students who have scored more marks in physics than female. Number of scored more marks in physics than male. Let's take a look at it. Here, if it is not male, it is considering it is female. So whatever is stored in the A is about males, whatever stored it is about females. So if we go by that logic, we have two options, either B or either D, right? So what we are looking at it here. Yeah. So just let's take a look at this again one more time. So tell me how the city D is being assigning values here. Hello, am I audible?
Yes, sir.
Yeah. So again, let's go. City D is an empty list, is an empty dictionary, right? Read the first
Yes,
row
sir.
X in table 1. If is key city D or X dot town, so there is no information regarding that. So it will not get into this particular if block, full if block. Then it will go to else block. Now what else block is doing? It is saying city D X dot TOWN, right?
Yes.
Is an empty dictionary. And then it is also
Sir, I guess we skipped the previous cells. X dot town / city and X dot gender.
Which one?
The previous one. We skipped the first if, but I guess we in the first if it will not iterate, but the else of that if is left, I guess.
Yeah. So see, it will not enter into this, right? Because the list is empty, right? So the the else block of this is this one, right? Else.
Okay.
For this if, this is the else. For this if, this is the else.
Okay.
Okay. That is why we are saying that it is defining X dot town. So suppose your first town was what?
Erode.
Erode. So city. Sorry. City D. Erode is an empty dictionary. Correct?
Yes, sir.
Then it is saying city D X dot town. What is that? Is what? Erode.
Yes.
And
male.
Male is equal to highest mark. What
Don't
is it?
remember the marks that were given.
So marks were some marks. Suppose 64.
Yeah.
64. Okay.
Yes,
So now you have
yes.
two instances. Now is this dictionary and is this dictionary both are same?
Yes, sir.
Huh?
Yeah.
So is it safe to assume that when you say that city D, you tell me how it looks like now?
There will be two lists in this dictionary, one with the erode and one with the town, city or town name, and one with the gender.
So no, like how it will be. Your key, first key will be just erode.
City or town name.
Huh?
Name of the city or the town. The first key.
Can you just speak again?
Sorry, sir.
Yeah, can you come again? You're not clear. It will
I'm
be
saying the first key will be city or the town name.
first key will be city or town name. So it
Yes,
will be erode in this sense, right? Then
yes, sir. And then
64.
the gender. Oh, then the gender.
Then M, like this.
Yes, and then the marks.
And
marks of the
64.
Yes, sir.
So, and then what about this instance where it is going to give you an empty list, empty dictionary? So city D erode, sorry, should store what?
It will store then it will first store the gender.
Gender.
Yes, sir.
Gender too?
Sorry.
Like this?
Yeah.
Yes, sir.
So it means that it should be something like this, right? Multi-key?
Yes, sir. Yes, sir. It should be something like that.
So even if you assume this, again, we come back to this basic. Is the first of LM?
In this case, the first of L will be M.
In this scenario, right?
Yeah, yes, sir.
So let's assume that. So if first of L is M, that is true. If city DI and first of L.
First of all,
That
So
means if erode and mail, the
Let
mark
me
stored by them is greater than the
city or
city
last
DI and last of L.
of this.
So that means the erode will store the last, whatever the last one is. Hello?
yeah, I'm listening to. So is it comparing the same thing from the list? First of L and last
No,
of L?
no, they are comparing the same cities but different genders. So according to the erode example, if we are taking the erode example, we have two genders. First one is male, and then the 18th at the serial number 18th we have the female. So according to that, if we are going then last of L. So first of L here is M, and in that case, they should have written. I guess they should have written the first of L, because then we'll have the female, and then we can compare the marks of both the genders. But they have written the last of L.
Yeah, but when you look, when we say that first of L is M, the first of L here is also M.
But the last
Hello?
is
Then last is what?
So the last of L in this case, the last of L is the marks of that gender from that city or town. So how can we compare the gender and marks?
I think, sir, here some compare cities a number of times.
How?
I yes compare cities.
Hello? Even in this scenario, right? Where did it go? Where did it go? Yeah, this is the one. So again, it comes down to the same point. How? Hello?
Yes, sir. Boy.
Yeah, some background noise, I think. Yeah. In line 5, what? Your voice is not clear.
So it's a background noise.
No, she's saying in line 5 something. Just give me a minute. I'll come back. Just give me a minute.
Okay.
Yes.
Yeah. Just 2 minutes. Yeah. Hello.
Yes, sir.
Yeah, I think in line 5 there is compare between first and last town and not. Who is this? Karthikeyan?
Yes, sir.
Yeah. What were you saying?
Yeah, it's comparing between the marks, the highest marks scored by the male in the city, male gender in the city, with the highest physics marks scored by the female gender in that city. That is what is being compared.
Yeah. So that is fine. Like, we see that, that is one of the options. What I am
Yes.
trying to ask you is how these keys are being processed and how you're calling those keys here in the dictionary.
So it is a dictionary of dictionaries. So city D of town is a dictionary itself.
City
And
D. So
of
give me an example. So what do you mean by
city D of Erode.
Hmm.
Is Erode is a sub-dictionary within city D.
Okay. So you mean to say Erode itself is a
Dictionaries.
which
Yes.
stores the information about M.
Yes. Keys are M and F.
Yeah. So maybe some marks say 64 and then say F is some marks with say 55.
Yes.
Or something of that sort. Then city D with Erode. Erode and then M is another dictionary.
No, sir. This is the final key value.
This is how we are calling the keys, right?
Yes, sir. It will give the final value stored in M.
Yeah. So in the previous what do you call it? In this code, what we were storing the highest marks scored by a particular gender, right? In physics.
Yes, sir.
Under the city. So if that is true, the way this particular code is executed, right? What it is storing is something like this, right? So you have city town. Just remove this for the sake of simplicity. And some marks, maybe, some 76 is there. That is being stored. And given that the town, suppose, was Chennai and gender was suppose female. So this is an entry to the dictionary called
City D of Chennai.
City D of Chennai. Right?
Yes.
Where you have a key called in this scenario, sorry.
F is the first key.
F is your first key, which is 76, right?
Yes.
And the way we are calling in here, right? Now, if you look at it, for each I in keys of city D, right? In this scenario, how many keys do you think there are? Suppose we have 10 cities, right? Suppose 10 cities were there. The keys of city D I stores what? List of what?
Male and females.
List of male and female marks, right? Highest female marks. Right, that is what it is storing. A dictionary with gender as a key map. The
Yes,
highest physics marks scored, right? For each
only
of
the
these.
keys, sir. Only the keys.
So it will have only either male or either female.
Yes.
So assuming that the first one is male. So say this will be equal to M or sorry, M and F. There are only two values in here. Right?
Yes, sir.
And what about then city? It should also iterate over cities, right?
Yes, sir. I depicts the cities. I is
city D.
Keys of city D is the list of cities.
In this particular statement, right?
Yes.
in this particular statement, the city D is different. Let me just.
Yes, yes, I is the city.
And for here, the concept is different. Okay. So this will give you a list of cities, right?
Yes, sir.
Right. So, and this will give you the
Male
list
and
of
female.
gender, list of
Yes,
genders,
list and-
right?
Yes.
And so when we say if first of L, we are looking at is equal to
List of gender.
right.
First of gender.
So we are just making sure that in some cities there could be just female. So we are just checking if first of M is equal L is equal to M, then it will go through. Now, if you look at this if statement, right? So we have if, then in this case, city D of I. So I we know is list of cities, right? For example, Erode, Chennai. What was the other one? Something of that sort. Okay. So the first one, it will go with the Erode one, right? So now the value of city DI is if is city D Erode, and the key which we are asking for is M, right? First of L. So first of L is what?
M's.
Of L. So there are only two instances. Either you have first of L or last of L. So it's a pair. So you have city. Again, it will be the same, right? City D, a road, and it will ask for F, right? And then it is saying that now you compare when you if that is true, if the mark of male student is higher than female mark, you whenever that happens, you increment by 1. Otherwise, in else statement, what is there? If city is Erode, right? No, yeah, if city is Erode and first of L is what?
F, sir. In this case, yeah. First of L is F.
F, then is greater than city again, because I will remain the same, right? Erode for this. So it will only compare for the first. And then it will look at M in this case. Last.
Yes, sir.
Then it is in increment. So if female mark is higher than male, then increment B. If male marks are then female, increment A. Now this is happening because of what? In what instances you may have the first of L to be M and first of L to be F?
For each cities.
Yeah, for each city. Suppose if you encounter F first, right? So in the list which is being generated, F will come first in the list, L. Because in here, what you're doing essentially is that the sequence of your list L, right? Your L is either M and F, or it is right?
Yes, sir.
So in some instances, it may happen that it is other way around. Is that what it is doing here?
Yes, sir.
Because if first of L is
Male,
M,
male means, does it mean that female has to be the first element in the list?
sorry,
Female must be higher than male means, does it mean female has to be the first element in the list?
no, you are not quite clear. The point, the issue which I have here is that, right, when you say keys of city D of I, right, whether it is male or female, will it always give in a certain order, or the order will depend on the way the list is being processed? The entire data is being processed.
Sir, that's what I want to say. Does the order depend on how the code is?
In what sequence we are getting the data, right?
Sir, does the
Yes.
female marks higher than male student means female has to be the first element in the list?
No. What you said? Why?
Oh,
The
Okay.
female marks are higher than male means, does it mean female has to be the first element in the list?
Yeah. So you are saying that if the female marks are higher, it should always be the first one. The order dependence comes
I am
from this.
asking.
Yeah, the way I see, right, when you say keys, right, you get a list, right? This is not an ordered list, right? When you say keys of any dictionary, right? Is it order dependent, or it doesn't depend on order?
Independent. Independent of.
If it is independent of order, you should always get M and F, right? List or F and M.
Be either.
Only one of it, right? But in either of the case, if the first letter is M, right? If first of this list is M, then it is definitely comparing whether the male marks are higher than the female marks, which is what the counter A is doing. And what is counter B is doing is that if the female marks are higher than the male marks, then it is incrementing B. What's the answer? You said B, right?
So the option A is the answer.
So you see that this is not exactly what it is doing, right? Your city D of I, first of L and last of L. So it is not male and female comparison, which is being incremented here, because your city is essentially
Can you just explain line number 9 to 11?
Yeah,
9,
9 to 11.
9 through 11, na?
Yes, sir.
Yeah. So yeah. So what we just hypothesized was it is a list of list. Okay. And yeah. A list
So
called
this is a dictionary of dictionaries is what I guess we hypothesized.
Yeah, so this is a dictionary of dictionary where we said that every dictionary like with a city name has two of the keys in it, either a male or either a female, with the highest mark put in that dictionary of for each of the city. And what we were doing is, if you look at it, else block, else, if you have if city of, say, Erode and say female is greater than city D of Erode and male, only then you increment. If this is the condition is true.
So here I is a particular city, sir, and it is constant for that comparison.
So if for each I in city keys in city D is what we assume that the city D itself contains the list of cities. So for each I remains constant. The city remains the constant. So for I, if it is Chennai,
each comparison, the city remains constant.
yeah. So in each, the city is Chennai here also and here also, and we are only comparing between male and female, whether their marks are whose marks are higher. If male marks are higher, then we are incrementing A. If female marks are higher, we're incrementing B.
So, sir, because the city is constant, so it has to be only either the female students and male students have scored the higher marks in a particular city. Comparison is in a particular city.
Yeah, comparison is among a particular city, and it is incrementing, right? The cities.
Yes.
Yeah. So what we are counting is, if this is the condition, right? If male marks are higher than the female marks. So this was the first one, right? So
Yes.
and this what we are doing essentially. Yeah. So here what we are saying is that if this is true, if in this scenario that this is list of cities, this is your male or female, what it is. So you're comparing among the cities, in the same city, whether in the first scenario male has more marks than the female, then A is encountered. So A is counting the number of cities in which this is condition is true, and B is counting the cities where female marks are more. So that is what it is, counting. So if you look at the full picture, so among each of the
Sir, the L stands for female students.
this one,
The line number 9, the L indicates the first of them.
this is for female. So if suppose you don't have M and L, so suppose your first list, your first in the list is not M,
So it has to be female.
F, yeah.
So it has
So
to be for these increments.
yes, so the first of L will be F. So automatically for a city, if the female marks are higher than the male marks, because it is binary, right? Either you have male or you have female.
Yes.
So you have only two elements in the list L. Assuming that the keys are generated either M and L or L and M, depending upon each of the I, we are checking whether, if first is M, then check for, if the boys have more marks than the girls. Otherwise, if the first is female, then you check whether female marks are higher than the male marks, and then increment the count. So here the number of counts for the city where female has scored more than the male counters is what B will represent, while A will represent where the male student has scored more than female students. So that is why you see that the answer tells you that the number of cities from which a male student has scored the highest marks than female, and B will represent a number of cities from which a female student has scored the highest physics marks than male. This is because we have created dictionary of dictionary by using these two statements in the else block in question number 7.
Yes, sir. Got it.
Yeah.
Yes.
So
Answer question number 9 and 10.
9 and 10 the same. Okay.
Yes.
9 and 10. Okay. The given pseudocode is executed using a dataset having the same field as the words dataset and contains the following words. She sells seashells by the shore. Seashore the shells. Okay. Word count is equal to 0 while 1. Yeah, what is your question in this? What will be the word count at the end of the execution?
So according to me, the word count is 12, but the answer is 5.
Let's see. Just copy paste this. Yeah, this is the statement. While table 1 has more rows, read the first row X in the table. If get something X is greater than or equal to 2. What does get something do? Hello?
Gives us the words.
Oh, this is the procedure.
Sorry,
Yeah, there it
procedure.
is. This is a procedure which we are calling. Is greater than or equal to 2. Word count is equal to count plus 1 and move x to x. So we have a condition where we are incrementing word count for a condition. Count. Okay, so get something does what? If we have I, then a dictionary letters, and then C is what? An empty string. While I is less than y dot letter count. Okay. So letter count. Essentially, you have first letter count is 3, right? So while 3, for she,
Yes, sir.
right? Yeah, 3 is less than or equal to y dot letter count. So say first row. Yeah. So if 1 is less than or equal to 3, which is not true, right? For the first one, let's say letter counts. Let's make a list out of this. Tell me what is it? It's 3, then 5, then 9, 2, then 2, then 3, then
7.
7.
Yes, sir. 8.
8.
3.
Then 3.
6.
Then 6. Then 3.
5.
Then 5.
3.
Then 3 again. Then
9.
9.
2.
2 and then 4. Okay. Yeah, these are letter counts. So let's look at one by one what get something is doing. Yeah. So I is equal to 1. So while 1 is less than 3, which is not true. So it will not go in here, right? In this loop. I is less than or equal
So
to
why won't it go here? I is
is
they have
equal
given
to
us I
1.
is 1.
I
And
is
1 is
1.
less than 3.
Yeah, 1 is less than 3. Less than
So
or
we'll
equal
go
to.
further.
So we do C is equal to ith letter of the
Word.
y dot word. C. Let's see. So this is true, right? And
yes,
is C is equal to ith letter of y dot word. So it is going through each of the word, right? Each of the letter.
Yes, sir. It's checking if the letter is vowel. Here in the first word, the last letter of the word is vowel.
Yeah. If C is vowel. So let's see. Is the first one vowel?
Not the first letter, but the last letter is vowel.
Yeah. So the first letter is not vowel. So that won't do. Second is also not there. E. Last one is right. Then
Yes, sir.
letters. If this becomes true, we have letters dictionary in which what we are feeding. C.
We are storing C. That is the letter of the
True, right?
yeah.
Then we are saying if this
We
is
are
true,
incrementing the
I will become 2.
True.
So we are just iterating through each of the letter, right? By using this particular
Yes, sir.
conditional. Okay, and then return length keys of letters. So key. So what does keys of letter? Keys of D returns list, right?
Yes, sir.
Okay. Yeah. So in every instance, when we have an vowel, right? it will return, it will just do the letter C is equal to true, right? And then when you call it here, if get something X is greater than 2. So if C is vowel, C is equal to true. I is equal to I plus 1. So let's look at the bigger word where we have more. Let's look at the seashell. Okay. So you have E, you have A. And then again you have E. So for the first one, if C is the vowel, side letter of the word, letter C. So C can be anything, right? In this scenario, C is not what it is. C is what? E in here, right?
Yes,
Hello?
sir.
Yeah. So in the next iteration, suppose in this scenario, right? First one is E. The second one will be A, right?
Yes, sir.
We'll have A, which is also true. Likewise, A again E. So you have only true, right? In this scenario, A and E. So this should return the length of keys. So it will return the, so keys gives you T list, right? So you have in this scenario E and A, right? And the length.
Yes, sir.
The keys in letter should return you 2, right? Sorry. So it should be greater than or equal to 2, then word count will be incremented. So you want to have all of the instances where the word has more than 2 or more than 2
Okay, so
word
sorry to interrupt,
counts.
but I guess what they're saying in this then is we go through each word and see if any word has 2 or more than 2 vowels. If
Yes.
there is a word which have 2 or more than 2 vowels, then we'll increment the word count. Otherwise, it won't increment the
It
word
won't.
count.
Yes.
Okay.
So
Got
in this
it.
scenario, what should be your answer?
In this case, if we are looking at the sentence, then we'll have the one is seashells,
this one,
the
yeah.
other is one is seashell, the other is seashore, then the other is again seashells and are and sure. That
So
makes
you
the
have,
5.
yeah. The answer
Oh,
is 5. Okay.
Okay, got it. Yes, sir. And the 10th one.
Yeah, number 10. What it is asking? The following pseudocode is executed using scores dataset. Let MPC be the list of sequence numbers of the students who have scored more than 80 marks in mathematics, physics, and chemistry respectively. At the end of the execution, Dic80 stores a dictionary with a sequence number of student mapped to the number of subjects in which the student has scored more than 80 marks. Choose the correct implementation of n sub in, it is an MSQ. Okay. You have a dictionary initialized to empty. And what do you want to store? Sequence number of student mapped to the number of subjects in which the student has scored more than 80 marks. What do you mean by sequence number here?
The 0, 1, 2 that is on the top of the card.
Yeah, the number of the card, right? Card number essentially.
Yes, sir. Yes, sir. Card numbers.
That's what it means. Okay. So that is being that is being mapped to. Which one was it? Last one.
10. Yes.
Okay. Yeah.
Sir, actually from what I can understand, What they're saying is they are storing like dictionary. Dict 80 is an empty dictionary where they are storing the subject in accordance to the sequence number. Right. So the main question that I have in this is the answer that they're giving is that is the first one. They are saying that to return the count. How are we returning the count when we have to store the number of sequence numbers?
See, what it says, it is the sequence number is mapped to the number of subjects in which student scores more than 80 marks. So you need to count the number of subjects in which it is scoring more than 80 marks. As long as your n sub is counting that, then it should return the count of each of the subject for each of the student who got more than 80 marks. So that is what it is doing, right? It should not be the sequence number. We should
Okay,
always.
so it's not exactly storing the sequence number, but it is storing the number of like number of cards.
So yeah, so it is storing the number of instances where this condition became true, where the particular student has scored more than 80 marks in more than 2 subjects.
Okay, got it.
So not more than 2 subjects, the map to the number of subjects, like how many in how many subjects he has scored more than 80. That is why you see that they have member here and they're looking at whether that is true or not.
Yeah. Okay.
Yeah.
And so I have a question from VK also.
Okay, what is VCAT question? VCAT, let me just check. Yeah, VCAT, practice assignment.
Also activity questions. So activity question point 2, question number. Yeah, question number 4.2, question number 4.
Question number 4, how many iterations are required to create a dictionary with keys, adjectives, and data set? Oh, this is very lecture based, right? Yeah, so what was resolve pronoun and its equivalent matching noun using dictionary and ordered list. So you have dictionary, data structure can be used for the thing. Yeah, so what was your question in here?
So
Exactly.
I did not understand how come in a single iteration can this be done?
So we have to, how many iterations are required to create a dictionary with keys, adjective, pronoun, and noun from the paragraph data set? Yeah, how many do you think will be required? How do you store a dictionary? How do you create a dictionary? When you iterate over it, right? How are you given that table?
First we'll have to introduce an empty dictionary, then we'll have to go further, right? We'll go, okay, got it. It will take only one,
Right,
right?
you just need one iteration. There you
one
have
iteration.
to mention what your keys are.
Yeah.
So that's why it will not. So what was the next question?
The next one is point 3, question number 2, and point 5, question number 2. So it's
This question number 2 and question number 3.
No, point 3, question number 2.
Yeah, activity question, no?
Yes, sir.
8.3 and 8. Yeah, okay. Consider the dictionary discussed in the class, train wise and station wise. What will be the value of variable D after the execution of the following pseudocode? B is equal to train wise and C is equal to station wise first of B. D is equal to last of C. Yeah. What does this dictionary store? Train wise information regarding the stations, the train wise. Hello.
Yes, sir.
Yeah, do they store, like, if I call this train wise 1 to 260, it will
Yes,
give
sir.
me the information of all the stops the train stops, right?
Yes, all the stations.
Yeah, all the stations. So it may have, A, B, C, D, E, F, G, S, any
Yes,
number
sir.
of stations, right? And what station
Yes,
wise
sir.
does? Station wise is calling the first of B. So station wise gives you information of whichever the what do you call it, station is, right? For that
Yes,
station,
sir.
which all trains are stopping. That is what it is giving you, right?
Okay.
Right.
So in
So
this case, we'll have to look into the data set, right?
so if you look at 12260, just let me quickly pull that up. So essentially, if you go to your trains data set,
I guess we'll go into the station wise. I guess it will be easier then, considering that they're asking us for the 12260 train wise, and station wise it's first of B.
no, what was the train wise? What was that? You tell me that.
12260.
Oh, it is not there in this. I have to look one by one. See, in any case, just take an example. Okay, let's take an example of. Yeah, what it is essentially doing, right? You just go to this particular card, which has list of stations, right? Where it is
Yes, sir.
stopping. You take the
Yes, sir.
first station. That means from where the train actually starts, right? Then we want to
Okay.
look at the data which is present in that particular card, in that station card. In that station card, what was the last?
Okay, so we are
Last
taking,
in the list.
so it's like in train wise, we are taking the number 12260, where we are going to the station which is the very first station of that train wise card. So from that station we are going to the last the station, the very last train that stops at that station.
Yeah, no. So in train wise data, it will tell you from where the train starts. Suppose it starts from Chennai, goes to
Yes,
Mumbai.
sir.
So the first
Yes, sir.
element will be Mumbai. Sorry.
Okay.
Yeah, Chennai to Mumbai, the first element will be Chennai.
Chennai.
So once you go to station wise, it will look at the Chennai station.
Okay.
Okay. It will have information regarding all the trains which are stopping at the train Chennai station, right?
Chennai. Yes, sir.
So in that, what will be the last of that option is what this answer
Last
is.
option. Okay. Okay. Got it. Got it, sir. And sir, point 5, question number 2.
Mm. 5.
So it's the below one. It's the otherwise it's a video YouTube.
Okay, activity question. Yeah, sorry. Question number 2.
Yes, sir.
Identify the procedure which creates a side effect. Only one option?
No, so the screen below didn't load completely.
Yeah, identify the procedure which creates the side effect. Find maximum value in the list. Sorting the list in ascending order. Yeah, what is your question in this? Deleting keys from the dictionary, merging to
So I did not
dictionaries.
get the question. Like I did not understand which option is the right one.
So far, whatever procedures we have created, right? What
Yes,
is
sir.
the side effect essentially is when you fudge your original data, right? Or when you change the way the original data was ordered, right? Or you're adding something extra to that original data. That is what we call a side effect is, right? So when you have a set of data, finding maximum value in a list, will that create a side effect?
No.
Okay. Now you are
Sorting the
sorting the
list will
list
create one.
in an asset, right? If you are
Yes, sir.
sorting the same list, whatever data I have given you, if you copy it and
So
then you sort it and send me that, in that scenario, it will not. But if you are sorting the list itself in ascending order, it will create a side effect, right?
yeah. So in that case, the sorting list will create one side effect, and merging of two dictionaries will create one side effect, and updating.
So even when you're merging two dictionaries D1 and D2 and storing that into D3. So if you first merge D1 and D2 and you are ensuring that D1 and D2 doesn't exist independently, and then assigning that to D3, definitely you're changing, your procedure is changing. It's creating a side effect. Your original data is being changed. And updating a list or a dictionary will definitely create a side effect, right? Because you're changing the original list or original dictionary.
Yeah. Got it. Got it. And practice assignment week 8, question number 2, 4, and 5.
No. What assignment? Week 8 assignment.
Practice assignment week 8, question number 2, 4, and 5.
Two, 4. Okay, let's look at 2. The following pseudocode is executed using the shopping bill dataset. Let D be the dictionary that maintains the following information. The category of the item purchased by a customer. Okay. So dictionary only has categories information. Choose the correct code fragment to complete the pseudocode. Yeah, what is your question in this? You understood the question, right? What you want, what needs to be stored. So
Yes,
the dictionary. Hello.
Yes, sir.
Yeah. The dictionary should store what? Hello.
Yes, sir. The dictionary should store the customer, the category of the customer, the
category customer
category of item.
Okay.
So we
Yes, sir.
have a empty dictionary, while pile 1 has. Okay. So you just have that iterator. Which of this following option do you think will do that? I just want the category to be stored.
So according to me, the option 2 will do the function.
Purchased by a customer. Okay. Purchased by customer. This one?
Just a second, sir. Sorry, which one?
Yeah, which one will do?
The option B.
B. Why
Yes,
is
sir.
that so?
So it's storing the category of the item that is bought by customer under the customer's name only.
So if you look at it, you have X customer name is being created as
Yes.
empty, right? And in that
Yes, sir.
you have a dot category, which is either true or false. So is it storing
Okay,
the
so it's not storing, it's
information?
telling whether it is there or not.
The category of the item purchase is not being stored. It is just storing true or false values, right? In it.
Yes, sir.
What is the correct answer for this? Let's look at it.
It's, I guess, for each extra list, they're not category.
First one is true or false? First one is
Sorry?
First one is an answer or?
No, the first one is in the answer. The option A is not the answer in question 2.
No, why is it not the answer?
Sir, actually, it's because or even though it's
just look at the first statement, right? For each A in X dot item list.
Yes, sir.
What it is doing? It is going through all of the item list. What it is storing?
Yes, sir. The item.
It is storing all the items, right? Do you need an
Yes, sir.
item, or do you need a category?
We need a category, sir.
Right. So
Category
definitely
of the
the
item
first
purchased.
the first option is not correct option. In the second
Yes,
one,
sir.
if is
In the
key D and X dot customer name.
Yes,
So
sir.
only if it is true, only then you create this particular dictionary. Otherwise, for each A in X dot item list, you have X dot customer name and you have A dot category. What do you mean by A dot category? Should it be
It
X
is
dot? Should it be X
that
dot
the
category?
item is present
or-
in that particular category.
Yeah, no, but should it be A dot category or X dot category? Category is a
X
feature
dot
of.
category.
Yeah. So can this be an option?
No.
Okay, let's look at the next one. Let's look at the else block. Okay, now both of them are same, right? For this one, the else block is different. For each A in X dot item list, D.
It's again storing only the item, not the category of the item.
Look at the last one.
In the last one, it's storing the item in under the category, and with the correct it's A in X dot item list, and it's storing the A dot category. So
What
this
about
one
the
will be the
difference between
answer.
this one and this one?
Yes, sir.
No, I'm asking what is the difference between the option number 2 and option number 4?
The option number 2 and option number 4. Okay. Just a second.
No, sir.
It's in the first line. The difference is in the first line. In the second option, they are saying if is key, and in the last one, they are saying
What
not is.
difference will it make when you have not is key and when you have is key? When you say when you are looking for a key, right? If you are looking for a key, if it is present, right? This is what it means, right? If the key is present for a particular dictionary and a customer name, you create an empty
Yes, sir.
dictionary. So it is wiping out all of the information which was already present in X and this dictionary,
Yeah.
right?
Okay, so okay, got it. So in the second one, it's even though
In these two
if the
cases,
key is
it is not
present,
doing
it's
that.
wiping out the key and then refilling it. Whereas in the last one, if it's saying that if the key is not present, only then it isn't making the particular key.
It is creating that key, and then for each A in X dot item, then it is storing that information. Okay, that is why that is the correct answer. So which other question you said? Question number
4 and 5.
4 and 5. Okay. The following pseudocode is executed using the station-wise card of the train data set. What will C represent at the end of the execution? Station-wise cards of the, okay. So you have C coming in here. Okay. So D is essentially your Monday to Sunday. And you have 0. All the keys initialized to 0. While pile 1 has more cards. Hit the top card. If the X dot station name is equal to Mumbai, for each A in X dot train list, for each B in A dot days. So the station-wise data set, right?
Yes, sir.
That contains the information regarding the train number and on which days it is running, right?
Yes, sir.
So X dot station name, if it is Mumbai, for each A in X dot train list.
Okay, got
for
it.
each B. Understood?
Yeah, got it. Yes, sir. Understood. Understood.
So tell me what C is representing.
Actually, in this here, the station we are checking for a particular station that is Mumbai, right? So in the iteration, we are saying that we are checking the number of days that the Mumbai station has the maximum number of trains. So here we are saying that in the D, we are checking for each B. For Monday, we are checking how many trains are there in that particular day, and increasing the number accordingly. Then we are checking for B, then the Tuesday, Wednesday, and so forth.
This
We're
counter
checking. Sorry.
No, go ahead.
Yeah, so we are checking so forth till Sunday. And then in the next, and after we move the x to pile 2, we are in the next one, we are checking that just a second.
What is C? C is a list of?
C is the list of the days that is the list of the days that there are maximum number of trains on the Mumbai station. So we'll say that list of the busiest days of the Mumbai station is contained by the C.
Okay. Which was the next question?
The next question is 5, sir.
The following pseudocode is executed using the word data set. At the end of execution, C captures the number of words with either all letters are distinct or at least 3 letters are appeared at least twice. Choose the correct code fragment to complete the pseudocode. Okay, it's executed on words dataset. We want to see what the C is, and if you look at the code, the C, we have a counter. C is initialized to 0.
Excuse me, sir.
No, C is initialized to 0, right? Captures the
Yes,
number
sir.
of words with either all letters are distinct or at least 3 letters have appeared at least twice. So we need to find the correct code fragment. So while table 1 has more rows, read the first row. If I is equal to 1, D is a dictionary, while I is less than or equal to x dot letter count. Okay. So again, we are looking at the same type of format, right? We are iterating through each of the letter. Then if is key, D and B. So if the letter is present in the dictionary, then we are incrementing the count. Else, D is if it doesn't exist, then we are assigning one value to that particular letter. And all of this for each of the letter, we are incrementing I, correct?
Yes, sir.
Then what we wanted to do was number of words with either all letters are distinct or at least 3 letters are appeared. So for all letters to be distinct, what criteria this dictionary should have? This is what it is testing for, no? The dictionary criteria.
Yes, sir.
Found is equal to A. For each y in keys in D, if D of y is greater than 1, A is equal to A plus 1, else found is equal to false. If found or A is greater than or equal to 3, C is equal to C plus 1. Okay, so what do you think the answer should be? So the dictionary which we created, right, dy, it will have a key for each of the letter which appears in the word, right? So suppose you have A, B, C.
So your voice is lagging.
Why is breaking now? Not proper audible.
Hello.
Hello.
Yes, sir.
Yeah. There's some issue with the network.
Yes, sir.
Okay. So yeah, where were we? Just a minute. Let me share the screen. Yeah, we were here, right? So the idea here is, hello?
Yes,
Yeah,
sir.
so D, suppose you have three letters, right? A, B, and C. So suppose A occurs in a word 3 times, B occurs in a letter, suppose 1 time, and C occurs in a letter, suppose 2 times. So 3, 2, and 1 is what it will be stored in your D for that respective letter, right?
Yes,
And
sir.
then we are looking, so what the condition was, the number of words with either all letters are distinct or at least 3 letters have appeared at least twice. So either there should be instances where it is only one, all of the letters are one, right?
Yes,
Whichever
sir.
have came, or at least 3 letters are appeared at least twice. So out of all the letters, only 3 should appear at least twice. That condition is what you need to check. So you tell me from that information which of the following code is true. What is
Then
it that
in
you need to
that
check
case, the
first?
option 2 will be the correct answer.
So if d of y is greater than 1, we are incrementing it, right? A is being incremented, else found is equal to false. If found is true, if found is false or A is greater than or equal to 3, we have C is equal to C plus 1. So what it is doing here?
But sir, it's not the right code because in the first one, it's not the right code because if we have found, then it will turn to false, not in the else. We have initiated the found to true. So if we have found the key such that it is more than one,
No, for
then
this, if this is the else, right? If we
yes, sir.
don't find any of this key, else it will be found is equal to false now. Either it is greater than 1. If it is not, then you put found is equal to false. Then the found will become false here, right? Because you have an or condition here, either of the condition can be true. So A has to be greater than or equal to 3. The say
But sir,
counter.
it's saying, but in the question, it's saying that at least like either the three letters are distinct or one letter is repeating 3 times at least.
Yeah, so A is counting the number of letters, right?
Yes,
You
sir.
tell me which option do you think was correct in this?
So I guess
For each
it's
y.
option 2.
Okay. For each y in
And
keys D, if D of y is greater than 1, found is equal to false. A is equal to A plus 1. If found, that is false, or A is greater than or equal to 3, C is equal to C plus 1. C plus 1 counts what? C captures the number of words with either all letters are distinct or at least 3 letters have appeared at least twice. Is it doing that in option 2?
in option 2, it's counting
Hello?
whether if the hello, yeah.
Suppose, yeah. Let's assume for D, right? You have 3 instances. One, there is 1, 1, 2, 3, 4, something of that sort. Okay. So Y value, when you look at each of the keys, right? Suppose for the first one, it is 1. 1 is greater than
Yes,
1?
sir. No, sir.
It is not, right? So the condition is false, right?
Yes,
It
sir.
will directly go to here. Or will it
Yes,
go
sir.
to the next one?
So it will go to the next one. But
The next one is again 1, which is this
again
condition is
1,
not
then
true.
it's again false.
Then next one is 2. Will it go? Now 2 is greater than
Okay.
1. That is true.
Yeah.
Now found is
That's
equal to
true.
false. A is
False.
equal to a plus 1. Now
A plus 1.
A is counting the instances where you have at least 2. Right?
Yes, sir.
And then found will become false because that is also being recorded in here in the false statement. Then if found or a is greater than or equal to 3. So found can also be true, right? Suppose this keeps on going on, found is true. And
Yes, sir.
this condition not necessarily has to be true, right? A is greater than or equal to 3.
Yes, sir.
Then C will be counted by 1. It will
1.
be incremented by 1.
Yes,
Yeah.
sir.
So which one is the correct answer?
I guess it's B only.
Let's check. Yeah. The answer is correct.
Yes, sir. Okay, sir.
So
Got it, sir.
that is what the condition was, right? Either it should be
Yes, sir.
counted only once, or it should be like some of the letters should have at least 3 letters
3
counted more
letters.
than that. Yeah.
Yes, sir. Okay, sir.
Okay.
Thank you, sir.
Okay. Stop the session for today. Okay. Best of luck for your exams. I'll see you next week. Okay.
Yes, sir. Thank you, sir.
Yes, thank you, sir.
Okay. Thank you. Thank you very much for staying till the end. Okay. Bye.